I welcome you all to our very first class where we are going to handle Dynamics 1. And for today, we are here for Newton's laws of motion and some little bit of basic friction. So I remember telling you that this is the second topic under Dynamics 1, which is topic 8 in Senior 5 Term 2. Now, the concepts there are a bit too complex, but I'm going to divide these sessions into two, and we shall complete the topic. So for today, we shall not have one shot for a lot of reasons, because students have a lot of issues with mechanics. We really need to handle the mechanics with a lot of care. And then we hand assignments, things like that, because it needs to be hands-on. You're supposed to try out everything. Okay. Now, we are going to divide these classes into two. Or let's even first go through what the syllabus really wants us to know under this. And then I'm going to show you the divisions, and then we finish today's class and then tell you when next class shall be. Are we together? Now, very fast, without wasting time, I've told you it is the second subtopic. You can see this is you can see here that this is senior 5 term to work. Okay, so don't be surprised if you're a candidate and the topic is giving you a 10. That is actually normal. So it is topic 8, that is Dynamics 1, and the very first subtopic, that is components and resultant. This was covered. That means if at all you're that student who has issues with this, you're going to find more issues with this class. So I advise whoever cannot resolve a force, whoever cannot get resultant of a force, you're really doing yourself a disservice. You're not going to pick anything from this class. You're going to just hate the academy. So please and please first go and watch that class. It's there on the drive and it's there on YouTube. Then what else? You realize that this is what we are supposed to cover. Do you see this? But somewhere they are talking of the equations of motion. And the equations of motion we are taught under linear motion, which is also on YouTube and it is also on the drive. So if at all you have issues with resolving forces, getting the resultant of a force, the three equations of motion, if you have never used any, if you don't even know how they look like, if you cannot derive them, you're not actually supposed to be in this class. So those first two things are very important. One, the resolving of forces. Someone may be like, Doctor, what do you mean by resolving? This is what I mean. That if they tell you that this is a force of maybe 5 newtons, and they tell you it is maybe at an angle of 30 to the ground, I mean that you can be in position to get the horizontal component and then the vertical what? Component. So getting those two components is what they call resolving. Then afterwards you get the resultant, something like that. So you really need to be aware of that. Now, now, um, if we try to go through, so this part of connected particles, it will be later on. Someone will be like, why later? We are applying Newton's laws. That means before even applying Newton's laws, you're supposed to understand what Newton's laws are. I don't know whether that makes sense. Okay, now when you look at this, they have a lot of things they have attached here. Okay, we are having the concept of friction, we are having limiting equilibrium. Are we together? Then we have equations of motion, we have the Newton's laws, then we have the application of both to bodies in limiting equilibrium. Are you seeing this? To bodies in limiting equilibrium and in motion on horizontal and inclined rough surfaces. So here they are talking of only and only rough surfaces, but for you to understand rough ones, you should know smooth ones. So we are going to include in the smooth. Let me hope that is understood. So there are things we are going to do today. That's why I've told you that this class is going to be divided into two, so that people don't really burn out. You understand? Okay? Now, hope that is enough. They are just applying all that to solve numerical problems, nothing much. So when I come here to our workbook, that's why I've told you that we are going to cover Newton's laws of motion and some little bit of basic friction. But don't worry, things won't change. Now, what are we really going to do today? So you've realized there are a lot of things to cover. First and foremost, it is better that we first review the equations of motion, just listing them, nothing much. So I'll put here review equations of motion. So I'm going to write whatever we have in the topic so that you people get the right divisions. So reviewing the equations of course of motion before you even look at the laws of motion according to Newton. Review the equations of motion. Then after that, of course, I'll hope you review something small concerning absorbing forces. That is so important. We are supposed to learn also that because, of course, they are going to be involved forces. You see that in the second law of motion. And then we shall now talk about Newton's laws of motion. We shall finally introduce them. Hope people are taking notes. Okay. Then after that, the motion we are going to cover is divided. So this is what you need to know. The motion is divided into two. There is motion that is on horizontal planes. Someone will be like, Doctor, what do you mean by horizontal planes? What we mean by horizontal planes, maybe you have something like this, the horizontal plane like that, and the body is just on top like this. That's what they call the horizontal plane. I don't know whether people now get it. I think I no need to overshade like that. And that is your body. That's what we call, and maybe the body is moving in that direction. You understand? This is your body. Something like that. So you can see the plane is horizontal. Are we together? Then we can also have motion on a plane that is inclined. That means the plane is at an angle. So we are going to come and say, or we can have motion, but this time round on a plane that is inclined. So I'm going to put here inclined what? Inclined planes. And how do they really look like? Now the plane is inclined like that. Of course, this is your ground. Or anything. It may not even be the ground. It may be the very ground that is inclined. So I'll just put this like that and then tell you that maybe we are having our body. Maybe there is a force pulling it up like that. Are we together? So this is your body. But then what I want you to realize that it is at an angle to the ground, maybe theta. Do you see that? Or it is at a certain angle to the horizontal. So that's how the motion is divided. But then there is something you're supposed to appreciate. That yes, we are having horizontal and inclined planes, but have it in mind they are either smooth or rough. That is something so important. Okay? Then when we come to the inclined planes, the same thing. They are either smooth or rough. So when you look at this syllabus book, there are some concern, and I want to show you this again. When you look at this part of the connected particles, the syllabus book included the smooth and rough, but then under Newton's laws of motion, it only talked about the rough. But you cannot understand the rough if at all you have no idea completely on the smooth, because you don't have a point of reference. That means you're prone to making errors. So you're going to forcibly cover it. And trust me, that was just an oversight by the person who wrote it. But they were supposed to be there from smooth to rough. So I've told you that we are going to divide today's class in a way that is student friendly. And I've told you that today we are going to look at of uh, that part of basic friction, just basic friction. Then next time, as we talk about this part of inclined planes, we shall talk about complex friction. I want to tell you that for that friction, it is complex. Yes, complex friction. We are going to talk about it. But that will be as we talk about the inclined planes. That's where the complex friction shall come in. And it is in this complex friction part that we shall talk about the concept of limiting equilibria. Concept of limiting equilibria. Because you will meet this thing so many times and it confuses so many people. Someone is like, what is that limiting equilibrium thing? Though as mathematicians, we shall not give it a lot of time, but when it comes to physics, that will be a long story. Are we together? Now, what are we going to cover today? What do we have for the next class? So for this lesson one, we are simply going to do this. So for this lesson, these are the targets. We are going to do this. We are going to review the equations of motion. We are going to review some bit of resolving forces. We are going to do Newton's laws of motion. Are we together? We are going to do the horizontal planes, and we are going to do both the smooth and rough. Now, this rough part, that's why we shall talk about basic friction. Are we together? You people, let me hope you know that friction is simply a force that opposes motion. And where we have something smooth, there is no friction, and where we have something rough, there is actually friction in place. So when I say it's under rough where we shall cover basic friction, let me hope you really get me. Are we together? Now, that is the whole plan. So those are the only things for today's class. Yes, you get? So concerning the inclined planes, concerning the complex part of friction, concerning the concept of limiting equilibrium, that will be covered under lesson 2. So you have the next stop. So lesson 2 shall be our next stop after this. So I'll come and say that shall be our next stop. So that is it, people. Hope you have the whole plan. So I always try to give you this so that you have a picture of all what you're supposed to know. So that even if you're just going for an exam and you're like, I'm supposed to do mechanics and we have so far covered Newton's laws, you know what is there, you know how everything is divided. So you just check and be like, where do I really have issues? Then you'll be like, I've not yet gotten well these inclined planes that are actually rough surfaces. I need to do something about them. You get the point. So for today, we are going to do almost 70%, and then the 30% shall be for another what? For another class. Hope people are ready. Now, the equations of motion. Now, in lesson 1 that we had for linear motion, it was under for us we put it under dynamics 2, but it was supposed to be under dynamics 1. But don't worry, they're in the same element of construct. So we are actually on the right track. So in that lesson, it's actually on YouTube. You can watch it. It's even on the drive. I don't want to waste time to show you all that. But we derived those equations one by one, from the first one to the second to the third. That's why I told you that at SSA we always secure our future. Whatever we teach, we give it time so that we never repeat. Okay, so I'm going to straight away begin with the review. Okay, and then tell you something small. But a review simply means that all students are going to really contribute and we are going to work together. So I want someone who can unmute. For today, I'm going to give out a lot of money. So I want someone who can raise up their hand, unmute, and tell us all the 3 equations of motion. But you're supposed to tell us what each letter means in the equation, because that is very paramount. One person to tell us all the 3 and what each means. Yes, Ryan.
Good afternoon, Doctor,
Yes, please. Good afternoon.
and other students. The first equation of motion. The first equation of motion is V is equal to U plus 8, where
I'm
V
listening. Where V, I'm listening.
is the final velocity
Then you
and U is the initial velocity.
proceed.
Then
Just proceed. I'm hearing.
A is the acceleration and T is the time. Then the second equation of motion is equal to S is equal to U. S is equal to 2. It is equal to S is equal to UT plus a half 8T squared, where S is the displacement, U is the initial velocity, T is the time, A is the acceleration, and T is the time. And the third equation of motion is equal to V squared is equal to U squared plus 2AS, where V is the final velocity, U is the initial velocity, A is the acceleration, and S is the displacement.
Thank you so much. Can you add on something small on that time? Time taken to do what? I want
Is
to
time
challenge.
taken? T is the time taken. Because remember, now for example, here on the first equation of motion, T is the time taken from one point to another point, or time taken to cover a certain distance or displacement.
That is very good. That is very good. Now, like for example, in the second equation, that small t we are saying is the time taken to cover that displacement, right? Is it what you mean?
Yes,
Then, like in the first and third, the small t, the time, is the time taken for this body to move from a speed of v to a speed of u, isn't it?
yes, doctor.
Yeah, if the initial velocity is rest and the final velocity was 20 meters, that means the time t is the time taken for this body to move from rest to attain this speed, not so? That's the only point that you missed
Yes,
out.
doctor.
So how much should I give you? I've told you that today I'm going to give out money.
20K.
Oh, 20K. Which line?
MTN.
You read it. I told you that I have a machine that sends money. So you're supposed to,
0760.
you're supposed to be very fast. You first rate. First rate. You first tell me again. V is
V is the final velocity.
the final velocity. Hope people are taking note. We are going to find these very words in the classes. V is the velocity, and then E is the initial what?
Initial velocity.
Initial velocity.
Then A is the acceleration.
Then A is the acceleration. Which letter should I put here? R or L?
L.
Okay.
Doctor, it is L.
I told you that you just look for the word rate, because even as you're defining it, you say it's the rate of change of velocity. So you make sure you see the rate somewhere at least. Okay. Then the T, you said it is the time taken.
T is the
What
time
else can
taken.
M mean? What else can M mean apart from acceleration?
Yes, doctor.
What else can the M mean apart from acceleration?
A
It
can
can mean
also mean,
deceleration,
yes, negative acceleration.
Can you tell me another word for deceleration?
Deceleration,
Retardation,
it is
okay?
actually, yes.
Okay, that is it. Okay, now I think the next person should be ready. You read me your number. You be very fast. The next person should be ready because we are going to
0760.
review the resolving of forces. So I'm going to put a question and I'll need someone to also come and review for us.
0,
0760
0760 96 96
96.
61
Yes.
18.
Okay, Farida,
Yes, doctor.
you say 20,000.
Yes, doctor.
Have you received it? Is it 20?
Yes, doctor, it is 20. Thanks, doctor.
Okay, thank you for reading as well. So for me, I told
Okay,
you that
doctor.
if you read hard, I will surely gift you all. So that is it, and that is very good. Knowing these equations at head and knowing what each letter means is very key because it will guide you on question approach. You know that oh, they are provided V, they are provided U, they are provided A, they are provided T, they are provided S. Something that is so important. So you need to know about this displacement, that it can also be the distance because now remember displacement is distance in a specific direction. So you can really use distance for that. You're supposed to be knowing all these things. Okay. So it's not even necessarily velocity, but it can be speed. Okay. Speed. So the question may say speed. So you're supposed to just be knowing that velocity or speed is the magnitude of velocity. So when they use speed, you know where to put it. When you use when they use deceleration, retardation, you know that those two are actually the negative accelerations. When they use displacement, you know that that is distance in a specific direction, so that you really are well conversant with everything. So I've said this retardation or the deceleration is actually the negative acceleration. Yeah, something that is so important. Now those are the equations of motion in order. The first one, the second, the third. If you need more information, you just go to that class I referred you to. Now, option 2. We are supposed now to review how forces are resolved before we can even do our first take examples. Okay? So I'll come and say that here we are going to resolve forces. So someone who really wants more money, um, you're supposed to be very ready. You tell us what we are going to do with reasons, of course, okay? Since we had a boy at first, maybe I'll go for a girl next. Okay, so assuming that we are having maybe you are at the airport, you're here, I don't know. I just assume that at the airport we have our body here and then it is being pulled because that's where I usually see people pulling things at an angle at the airport. So assuming we are having, I'm going to use this as the point of reference, but in most of the cases, the best point of reference is the center. But never mind, we can also have it here. So assuming that this thing is being pulled like that, are we together? And maybe this thing is being done at a force of maybe, let's say, 20 newtons. Yeah, let's say 20 newtons. Okay, something like that. Then what they call resolving forces is getting two components. So when they say resolving forces, understand that what we are doing is obtaining components. That is the first thing you're supposed to note. So we are going to come here and say that here we are obtaining components. Okay, and then what are those components we are really obtaining? We are having, of course, the vertical component, very key, the vertical component and the horizontal component. That's what they call resolving. Then these two can later give us the resultant in one way or the other. Now, which one is the horizontal component? Of course, it will be running from the point of the action of the force, of course, horizontally like that. And it will be in that direction because this is the direction of motion. Then we shall have the vertical one. The person who is going to raise up your hand, make sure you're very sober. Because the moment you miss out, that means I'm not giving any other person a chance. So this is the only thing we are going to use. And then, okay, that's where I'm stopping. I've said that whoever is going to raise up their hand, please be sober. So that's our ground like that. Okay, I can see. I'm not seeing any girl. That means most of the people who are here have not actually watched the class of resolving forces. I'm not seeing any girls, so no one is going to give it a try. Yes, Engineer Sonia, unmute. Or Hanera Pauline, anyone? Anyone ready?
But doctor, we don't have the angle.
Yes, please.
We don't have the angle.
Yes, that's what I wanted you to say first. So you cannot resolve if the angle has not been provided. Okay, so that is so good. So the angle that I'm going to go for, let me go for, but make sure you have a clear background. Let me go for 30 degrees. Okay, thank you for that. You've already passed the first test. After that, what next? How are you going to obtain the horizontal component?
So we have a force that is moving on the vertical axis, that is we give it as Fy, force Y, on the Y axis. And then we also have
Yes,
the
and
one we have the one
I
that's
just
going on
want you to
the
tell me how you're going to obtain the vertical force. That's all I want.
okay, for the Y axis, for the force Y that I've given, we're going to have
And why are you saying y-axis, x-axis? Those things are wrong. Here we simply have the vertical plane and horizontal plane. Don't say those things of y-axis, x-axis. I don't know who told you those things. Just say what I want. All I want is the vertical component and all I want is the horizontal component. Just tell me we are doing this for the vertical because of this. That is all. Don't give me stories.
okay, for the horizontal, we're going to get cos theta of Fx.
You dodged the class. You dodged the class. You dodged the class. You dodged the class. Yes, blessing. Yes, blessing.
Good afternoon, doctor and other guys.
Please proceed. Vertical component and why?
Like the vertical component is 20 cos 30 degrees
Why? Why cos not sine?
because we are compressing the angle.
How are you compressing that angle? Let me ask you. I'm going to draw for you two arrows. There is this arrow in red, and then I'm also having this arrow in lemon green. Of those two arrows, which one is giving you the vertical component?
Oh, the vertical component is the one in green. Sorry, I made a mistake.
You
It's
understand? So
yes,
it's only when you're compressing that you use cos, right? And
yes, and
we are realizing that the compression is giving us the horizontal component, isn't it?
yes,
So that means here in red, it's where we have compression and we shall have 20
cos
cos
30.
30 degrees, not so?
Yes,
Yeah. Then for the vertical component, what shall we have?
it's 20 sine 30 degrees.
Because now that will be the reverse. The moment you compress on one side, that means the other one shall be the sine, because the compression shall have taken the cos, isn't it?
Yes.
Can you tell me the units? Can you tell me the answer to this? Is your calculator supposed to be in degrees or radians?
Um,
I said I will get you. Is the calculator supposed to be in degrees or radians?
supposed to be in radians.
You tell me, how do you read this thing? This one. This one I'm circling. How is it read?
Degrees. It's
So the calculator
supposed
is
to be
supposed to be in
in degrees.
You see that math is not hard, it's you makes it hard.
Yes.
So because that one is read in degrees, even your calculator, you should make sure that it is in what? In degrees, which is abbreviated as deg. So that is something so serious and it usually confuses people. If you want to learn when radians are used, you're supposed to go now for the iterative methods, which were also taught already. So you put your calculator in degrees and tell me the answers to this, because there is some other question that I have for you. Do you have your calculator there?
Yes, I do.
Please get it, make sure it's in degrees, because even the angles are in degrees. And then I ask you the last question, because me, I know the answers, because of a lot of time I've spent teaching the same things, but I want you to first press and see. But for the horizontal component, for the vertical, I think you're supposed to get something like 10. And then for this one, it's supposed to be 10 root 2. And 10 root 2, that will be 10 times, I think, 10 times 1.7 to something. We shall give you 17 something, I think.
Yes, it's 17.3.
You see, I know math. 17. Now, I want you to be good students. There is something that I really want to teach you. Okay, you're saying 17 point?
17.320.
Okay,
Five.
now, first stop there. You first tell me, how many decimal places did I talk about in that class we had? You remind me, how many?
5.
5, thank you. So you read 5, 17 point?
32.
3, 2,
05.
0,
050.
5. 0, 5,
Yeah.
0. So we can stop there, right?
Yes.
You tell me, what is the unit for the horizontal component? Is it kilograms? Is it grams? Is it moles per liter? What is it?
Newtons.
Newtons, because we are simply resolving a force and forces are measured in newtons.
Yes.
Do you do physics?
Yes.
Oh, what is the other unit for newtons? Is it is it the same as kilograms meter per square seconds?
Yes.
Oh, that is good. Did you attend to dimensions?
Yeah, I did.
Okay, then this one will simply be 10, and it is also a vertical component of a force, so it will also be newtons. So you people, that is all about resolving. Okay, now you see you have missed the money because we have actually been doing this together. So that means if at all I'm to give you the money, we are supposed to share. So that is it, people, about resolving. Nothing much. Nothing much, and you're supposed to take it serious. Other complex things, you find them. Where a negative comes in, a negative, of course, comes in where the force is going to look the other side. And then where it's going to force down, you people know what to do. For example, if at all this is the car force, and this car force is already looking down like that. I know that people know that. And maybe you're having something like 5 newtons, and then you're having something like let me call this maybe 60 degrees. Okay, I don't know if people can also handle that, because this is now a bit serious. But all these were taught. I'm just simply giving you a review, because I know there are those stubborn people who can never really do the needful. So all of you write the vertical component in the chat. So I don't want to see people having these things of x-axis, y-axis. At least call it the x-plane and y-plane. Okay? Because there are people who use it as, there are people who say F1, there are those who call F1 fx, there are those who say F2, there are those who call F2 fy, which is okay. And I also say that. But never talk of axis. At least call them planes. So all of you write the vertical component in the chat. All of you write the vertical component in the chat. You see, some people are still using sine. Why? Some of you crammed that every time you're getting the vertical component, it's supposed to be sine, which is wrong. So you're supposed to look at, are you really compressing the angle or not? Like for this case, for you to obtain the vertical component, you're supposed to do what? To compress that angle. So it will be 5 cos that angle because it is being compressed. And never forget to put the degrees here. Okay, and because we are facing down, that's why people are adding what? A negative. Then you tell me the horizontal component. What of the horizontal component? How is it going to be? Horizontal component, how is it going to be? Horizontal component. Horizontal component. Oh, someone is already failing. Someone is already failing. I'm seeing someone bringing in a cos 60. I don't know why they're saying that. Seeing someone saying sine 30, which is not right. Sine 30 is already here. So this one we shall be moving away. So this one shall be negative. This will be sine 60. And those who covered trigonometry with me, you know that sine 60 is cos 30. That is the complementary rule. So when you see someone here having sine 60, it is very okay. When you see someone there having cos 30, I mean, it is very okay. Someone may be like, what do you mean, doctor? The whole thing here is actually 90 degrees. So the other thing you're not actually supposed to forget is that as you're resolving or after you put the components, never forget that that angle. That thing that means now we are at that thing of 90 degrees. Is so important. Okay. So even here, so someone might have said that since it's 90 and we already have 30, that means this angle remaining is, since the total is 90 and we already have 60, that means the balance is a what? Is a 30. Are we together? Now, if at all you want to get this component, someone may be like, I'll be compressing the what? The 30, which is right. Remember, as you compress, it will be cos. So someone can have it as negative 5, but cos 30. So this one is also what? Right. That means even someone, in case we didn't have the 60 but had the 30, that means even someone who had said negative 5 sine 30 is also right. But you just need to understand the complementary rule from trigonometry. And I told you to cover it, that every time you're having cos here, and maybe in the same expression you have sine, these angles are supposed to just be totaling up to 90. And that is all. What do I mean? That if you're having sine this side, it is the same as the cos. Provided the angle that is here just makes a total of 90 with the angle here. So all of you press the calculators, put in sine 40 provided the calculator is in degrees, and then cos 50 provided the calculator is in degrees. You will see that it is the same. Just get any angle. Cos is the same as sine. On condition the angles here make a total of 90. For example, put here 15 degrees and then put here 75 degrees. You will see that the answer here is the answer here. Nothing much. Okay? That is what they call the complementary rule. Now, the other thing I taught you was just simply cosmetics. Cosmetics in these things. And what do I mean? That if at all this has been your course, this has been your force, and it is the 20 newtons, okay? And then you're having this. I know that instead of having this thing here, you can just come and have it here. You can just come and have it here like this. Like that. I don't know whether people remember that. In that if at all you're having here your angle maybe the 30 degrees or whatsoever, instead of having this force here, you just have it here. So that you just have an enclosed system. And then you come and put that 90 degrees sign. Then you come and rub this off. I don't know if people recall those cosmetics. Okay. So that you just be like, this will be simply 20 cos 30 degrees. Never forget the degrees. And then this side, it will be the 20 sine 30. Never forget the degrees. But these were just cosmetics, all in the name of having an enclosed system. So that's a simple review concerning the resolving of forces. Those who need full details, you'll have to go and visit that class. So guess what? We have now fully covered. We have reviewed the equations of motion. We have reviewed the resolving of forces. So let me hope the review has been worth it. You know which words mean what, which letters mean what in the equations of motion. You know how to deal with cos and sine in resolving. You know when we have negative and positive. You know the complementary rule, and you also know the cosmetics in actually the drawing of force diagrams. Okay, now straight away I'll go to the third part of the class, which is the Newton's laws of motion. First, tell me in the chat, did you cover Newton's laws of motion in O level? Let me see those people. Let me see those people who really paid maximum attention at O level. Newton's laws of motion. Please tell me. So we are going to have the first law. You know, you people are just good at saying yes in the chat. Everyone you see, yes, 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 yes. But the best student is that student who raises up or who puts their hand up and then they say, Dr. Yes, we covered that and I would want to give you the first law. I would want to give you the first and second law. I would want to give you the third law. I would want to give you all the three laws. Something like that. So I want someone, this time around a boy, Bate Jeremy had to put the school. You see, these are people who are proud of their schools. Bate Jeremy from Mengo SSU at the district. Mengo SS is one of my former schools, though I studied for only one term and then left. I remember I think I first went hostel and I couldn't manage hostel life and I went back home and I changed school. I went to some good school there in Masaka. Most of you know it. But I also didn't spend there more than 2 months. I left and went to another school. And pass. Yes, Bate. I think Bate is not ready to speak, but the mic is unmuted. Yes, Engineer Joshua, are you ready to tell us the Newton's laws of motion?
Yes, Doctor.
Please
Yes,
proceed.
good afternoon, Doctor and other guys. The first law states that a body remains at rest or continues moving with constant velocity in a straight line unless acted upon by an external force.
That is very good. Do you know the second law?
Yes,
And what does it say?
it states that the rate of change of momentum of a body is directly proportional to the applied force and occurs in the direction of the force.
Do you know the third law?
Yes, Doctor. The
Mm-hmm.
third law states that action
Mm.
and reaction are equal but in opposite direction.
Opposite direction.
Yes,
Do you know the formula of the second law?
yes, Doctor.
You state it. These are the people I
It
want. You
is
state it.
force equals m, where m is the mass of the body and a is the acceleration of the at,
Very good. Do you have an active mobile money number?
yes, Doctor.
How much do you want?
30K.
30K. You read it.
Yes, Doctor.
07
0756
0756
18
18
92
92
66.
66. Do you have it there?
Yes, Doctor. It is
It
the
is
one I'm
bringing
using.
it is bringing Joshua Rutaya. Are you my namesake?
Yes, Doctor.
You have said 30K.
Yes.
So do you know about that expression for normal reaction from the third equation of motion? Do you know anything about it? Hope you have received the message. Have you gotten the money?
Yes, Doctor. Thank you very much.
Is it 30K?
Yes, Doctor.
Okay.
Doctor, thanks very much.
You're welcome, sir. Thank you for reading books also. So, he has stated those laws very well. You people just make sure whatever I ask you, you respond. Even if you tell me, doctor, for me I want 500,000, I'm going to send you that money, provided you've read, you've understood, and you're really progressing academically. So just make sure whatever I ask, you respond. Whatever I ask, you respond. But the people who are responding are not serious. They're asking for 20K, 30K. I want someone to come and shock me, doctor, I'm going to respond, but I want 1 million. My dear, I'm going to forward it immediately. Okay? Money is just paper, and money is an earthly thing. So you respond correctly. You tell me, doctor, I want 1 million, I transfer immediately. Okay? So he said, we're not going to waste a lot of time. I think he just said these things perfectly, and we are going to just read them from here. And he said it the best way I really wanted them. Yeah? He said that law 1, that everybody continues in its state of rest or uniform motion in a straight line, or someone can say uniform linear what? Linear motion. You understand? Yeah. Unless acted upon by an external force. You know that. If at all the body is in its own moods, it does not want to be interrupted, it's not going to be interrupted. So it will just continue to rest. If it is moving in linear motion uniformly, if the external force doesn't act upon it, for it to, okay, it's like the body will keep minding its own business unless someone else wants to intervene in the business, but the body will just do its thing. And that's what the law says. You understand? Okay. Then there is the second law. Someone may be like, doctor, are we really supposed to know those laws? As math students, no. So as a math student, all you need to know that Newton in law 1 said that the body minds its own business unless someone really provokes it. Okay. You remember the Khoisan, the ones that were so peaceful unless provoked. It is this body. Then law 2 is actually the high yield here. It's the one that is going to take us to the calculations. And what are they saying? They are saying that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. When a student reads for me this law like this, I just realize they are really physics students. But then the math students, first we have hours. You understand that is a bit cheaper. Okay? That is a bit cheaper. And what you're supposed to know is that this formula of F equal to MA is the formula that is attached to the second law. Just get it like that. There is no rocket science. There is a topic called the Hardy-Weinberg principle in biology, in genetics. You just need to know the formula and what P means and what Q means. Only that. You get the point? So if I tell you that the force equal to MA, which you already know, if I tell you that it is attached to the second law, you should be understanding that clearly. But then someone may be like, doctor, where is this thing really coming from? We really need to know. Are we together? Now, this is what these people are saying. That the rate of change of momentum, I want you to listen very well. The rate of change of momentum is directly proportional to the applied force. So someone tell me, what is that momentum, or what is momentum? So there are two things we are supposed to explain here. I think I told you about the meaning of the word rate, but I think that was to physics students. I think we are covering something else. But when they say rate, this is what you're supposed to know. When they say rate, have it in mind, they are looking at a component of time. And I told you that when they say rate of change, here they have just said rate of change of momentum. I remember telling you that when they say rate of change of x, they mean the change of x. When they say rate of change of x, I told you that they mean the change of x, or someone can say change in x, and this one is always over the change in time, or someone can just say what? Time. Are we together? Of course, time is the same as change in time. If I say that your paper of math is 3 hours, that is time, the duration. But if I say it's going to move from 2 p.m. to 5 p.m., that is still change of what? Time. Like it has moved from 2 p.m. to 5 p.m. But someone else can say it's going to take 3 hours. So change in time can be, okay, they are just synonymous, if I can say. They are synonyms. They can be used interchangeably. So the time is simply t. Then the change of x, it can maybe from x1, maybe from one value of x, I taught you this also in linear interpolation and then in coordinate geometry, that the change in x of course change means subtraction. Okay, and I told you that you can either maybe have x1 minus x2, maybe x2 minus x1, whatever you want, provide. But don't overmind about that. Just understand that when they bring in the rate part, they mean a denominator of time. They mean that time is coming in as a denominator, then the balance after the word rate is the numerator. Nothing much. So when they say rate of change of momentum, you now know what rate means. Now, what is that momentum? What is that momentum? Write for me the formula of momentum in the chart. Write for me the formula of momentum in the chart. Let me teach math students some physics. Rate of change of momentum. That means if they talk of rate of change of momentum, what is the student expected to have? A student is expected to have the change in momentum on top. Student is expected to have change in momentum. You just go to the internet. Just go to the internet. Change of momentum out of the time. Okay? Now, let me see what people have given me in the chat. MV. Thank you so much. So I told you that V is for velocity, but you should know that the magnitude of velocity is speed. So when they use speed, you're supposed to be well conversant with that. Now, when they say that this momentum is MV, you all know that this M, you learn some physics today, math students. This M is mass, and mass is a constant. As we are calculating, we don't really expect mass to change. Okay, we are just expecting it to affect things like inertia. Okay, now, but this velocity is actually something that can change. This velocity can change. Let me tell you, if a car is moving, the mass of the car cannot change, but the speed at which it moves can really be altered. Are we together? Now someone can be like, how is this velocity going to really change? Okay, now I can tell you that this velocity can change from the initial velocity to the final velocity. Do you see that? You understand? That means if the velocity can change from u to v, that is initial to final, that means that even this momentum can change. Okay? That means even this momentum can change. And since momentum is mass times velocity, that means momentum shall also be changing from what? Shall be changing from mu to mv. Do people get me? Because you're just simply supposed to multiply mass with speed. Okay, now if the velocity can change from u to v, that means even the formula of momentum can change, or even the momentum can change from mu to mv. Hope people have gotten that. So with that, you can really get the formula for the rate of change of momentum and be like, the change in momentum shall be mv, because it is the final, so we expect it to subtract the initial to be on the surface side and then out of the time. Do you see that? Hope you're learning something. I want you to derive the other thing that these people are talking about. So what are you going to get from the rate of change of momentum? M is common. Are we together? Then here you're having V minus U as what is remaining, then the over T. I don't know whether people are getting that. So that is very, very important. Very what? Very important. Now, I want to tell you something still. I don't know whether people are aware that we have the first equation of motion, which you all know. So I'm going to first remind you and tell you that from this first equation of motion, which is like this. Do you see that? Do you see that? If at all I'm to make the subject, remember here we are having V, we are having U, we are having T. We have the U here, we have the V there, we have the U, we have the T. So we can be forced to make the subject because we are smelling something fishy. Okay? And what next? I told you about making something the subject. That first make sure it is on the It is on the left-hand side and it is there alone. Okay, so you can first have it on the right meanwhile. Do you see that? But then it is supposed to stay there alone. So I will divide by t like that, and then maybe afterwards I'll bring it on the what? On the left, and then show that the other side I have v minus u over t. So do you see that the whole of this, the v minus u over t, is actually a perfect substitute for that? Do you see how rate of change of momentum really changes to ma? Do you see that? So finally, the rate of change of momentum turns to ma. So as other people are complaining, telling you that ma is really meaning force, you tell them no, it is actually rate of change of momentum. And you should be in position to explain to those people what you mean. So rate of change of momentum is the what? Is the ma. Now we go back to the law. The law is saying that the rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction of the force. So all we want to know is that directly proportional to what? To the applied force. Are we together? Okay. Now, there is something you're supposed to note, that the F we are using in this question, it should always be the resultant force. That is very important. That's why I told you in the beginning that if you have issues with getting the resultant force, first please work on that from the lesson we had of forces. Then you come here and it will just be perfect. Okay. Now, the rate of change of momentum is ma. What are we supposed to do after that? They are saying that this rate of change of momentum ma, they are telling us that it is directly proportional to the resultant what? To the resultant force. Yes. So you all know in mathematics that if at all you're to remove this proportionality sign, we can first shift positions and be like F is directly proportional to MA. So you all know that if you're to remove that proportionality sign, you put equal signs there and a constant, okay? And then the others remain the way they are. So we shall have our F still there, we shall have our MA still there. Now, there is something that I really want to tell you, though we talk about it in physics. Yeah, though we talk about it in physics, but it is also ways that you people learn it today. Someone may be like, how does that K really disappear? How does it really disappear? And I know no one can tell me that, because now K is an unknown, but for us, we don't want to see it there. So it really disturbs, but let me shock you. This is what is assumed in physics. So they assume, or they tell us that a force of 1 Newton, okay? They tell us that a force of 1 Newton, what does it do? We really want to know. This force of 1 Newton always produces an acceleration, okay? Or let's write it like this. Well, actually, let me just tell you the story and then I attach the figures. You should be good people. We should be people who are good at taking notes. So this is the whole story. That when a force of 1 newtons, are we together, acts on a body of 1 kilogram, that body accelerates at 1 meters per square seconds. I taught you all these units in linear motion, so don't expect me to say a lot about them. So people, because of that 1 equaling to the K into 1 into 1, the K turns out to be a what? A 1. Don't think that we have just let these values to be 1, 1 throughout. No, we have just gotten the thing from physics. That according to physics, when a force of 1 Newton acts on a body of 1 kilogram, it produces an acceleration of 1 meter per square second, or that body accelerates at that rate. Nothing much. So on substitution, guess what? We get the value of K as 1. Are we together? And hence the overall result of those two, we shall come up with the force, which shall be MA, like that. So that's how the thing comes about. But it's all coming as a result of what? The second law. Let me tell you, the calculations are the easiest, but you also need to appreciate this little science. I just pity the physics students, because when you reach that part, we have a lot of things to derive and connect to in the different topics. But it being a math class, I need to control myself and know where exactly I'm supposed to stop. Okay, so F is the force and it is the resultant. Okay, so this acceleration, we talked about it in linear motion, you know. This m is just mass, everyone knows that. So in this mathematics, I will always prefer, and I really beg, let this mass be in kilograms, I told you that, and let this acceleration be in this, okay? Then this force is resultant, that is the first thing you're supposed to note, and it being force, we don't expect any other unit other than what? Newtons. So those three things are so important: the unit of mass, the unit of acceleration, and that of the force, which is in this case resultant force. So the moment you realize you're discussing with a friend who doesn't want to make the force resultant, warn them. If they are dealing with a question that is giving them mass as grams, warn them. Tell them you don't know what you're doing. You tell them that they just cram the things. Okay? Now, straight away, first take example. You see, we have used over 30 minutes just to explain the principle. And I'm going to do about a few numbers and then we leave this place. But I always want to have a very introduction so that even if our international students want to look at what Ugandans study, they really appreciate. Though you share some topics, though not in the same way, though they are not taught in the same way. This is a Newton. This is Newton 1. I'm sorry that I've put his name in small letters, but I think I don't care. First take example, we are getting it from our book. Okay, so I'm going to come here and say examples. Okay, now what are we going to do first? Okay, come here. They're saying that find the acceleration produced when what? When a body of mass, this is 5 kilograms, experiences the resultant force. When you see the word resultant, you just clap. Just be like, yeah, I've made it. So for some good time, I've been teaching you how calculations are made. And I told you, they don't mark formulas in math. So you can make a summary. If you don't make a summary, you can just summarize from the question. So I'm going to use the first example to make a summary. Okay, no. I'm going to just use the first example to summarize from the question. Then for the second, I'm going to write. Then I see what we have. Okay, now, when they say find the acceleration, I'll come here and put A. Remember, these are math papers. They usually give you spaces, so you're supposed to make the paper as dirty as you can. Then this is mass 5 kilograms, so this is M. So you just put letter M. That's the summary I mean. Then resultant force, like that, F. You see, there are things you're supposed to learn as students. Let me first see whether people really watched my class. You people, we have the word resultant force and we have these two. Then we have this. Which one is the right abbreviation of resultant force? Is it the first one or the second one? Resultant force. Resultant force. Which one is the right one? Which one is the right one? Of option 1 and option 2. You really need to be writing the mathematics correctly. Or someone is talking of Escamodo. Yeah, those are people who have been with me since day one. You see that people are saying 1, others 2, others what. Which is okay. Which is okay. But let me tell you, the quantity is force. So this letter F is very key. This resultant part is just a property of the force. That's why they tell you that function may be maximum, because it is the function that is the main thing. This maximum value of the function is just what? It's just something. They tell you volume maximum. I taught you that in application of differentiation. It is on your drive, senior 5 term to work. It is topic 10. You can watch those things. Most of you just want to be here with me, but you're really leaving the drive lonely, yet it is something you need so much. It has really made results and I'm totally impressed. Okay? And I believe students can do the same thing. Just because the problems senior 5s usually have, they look at the little work they have covered, forgetting that teachers are concentrating on senior 6s. So when teachers concentrate on the senior 6s, senior 5s get a feeling that things are cheap. Some don't even want to have holiday classes. Some even be like, let's just revise what we have started, forgetting that they have only studied 5%. And they are not aware that teachers are waiting for them in senior 6 to pressurize them, so that only 2 people in the whole school get 20 points. As other schools which plan well get over 20 students with 20 points, because they make sure that those students have notes first and foremost. Then they just explain using the whole of senior 5. If they are too late, senior 6 term 1, and then they revise for 2 terms and they make it. But I see students really taking A level lightly, and I be like, this one is going to fail, this one is going to pass, this one is going to fail, out of experience. And I know it's supposed to happen. But I usually advise you, some don't listen. I don't know why. So you're supposed to take this level so serious. Make sure you cover work. By now, a serious student should be done with all the 7 lessons of trigonometry. I have tried to put those things on the timetable. Whoever is going to follow week 2 timetable, you're going to be a very good student. Because yesterday, all physics students, even those who are listening to me now, if you never completed progressive waves, then you have a problem. Today we are studying the whole day, but tomorrow there are things you're supposed to cover on your own from the drive. Imagine in just 1 week, we're going to do lipids, we're going to do proteins, we're going to do nutrition, we're going to do coordination. Are you listening? That is biology. Physics, you're going to do modern physics. You're supposed to complete waves, you're going to do it quantitative. The math students, I expect you to be covering trigonometry on the drive, and all of you chemistry students are supposed to be done with alkenes, which are there on the drive. So if you don't follow that timetable well, you may not benefit from this. But I tell you, things that work, people don't want to adjust and adapt to the new environment. But it will really affect you. It will really affect you. My role is to communicate in the channel and make sure the communication reaches you all. But I don't have the time maybe to be coming and talking to you in those different groups. But in third term holiday, I usually have the time. I'll be getting time with Jazz. But then it will be too late for you to change. I will now be talking to the vacists, encouraging them to cover A-level work immediately they are done with their last paper. And I think some of you have realized that you're really regretting. You're like, why didn't I start these things immediately after my vacation? But you were just there. You're like, let's wait. We are in vac what. The real vacation is the one of senior 6. This one of senior 4, it's just term 2 holiday. It is just Christmas holiday. The real holiday is that of senior 6. In that after that, you can even decide to go and do business. You can go to technical schools, vocational schools. You can go abroad and work. After all they need is a passport, and all that is needed for a passport is a national ID. So encourage your friends in senior 4 to cover work early enough, unless you want them to really struggle like you guys. Of course, some of you. I gave you the preparation drive for classes. Some of you ignored it. Those who made good use of it, I think you can give me testimony. Just because when people reach school, teachers teach these things and they understand so fast. Then they forget SSA. At that moment, they cannot tell that it is knowledge of SSA that is making the lesson smooth. Not until they engage with friends and realize friends are struggling, then they get to know that, oh, really, SSA was worth it. So always do the needful. And you're supposed to be getting sessions for me to just come here and talk to you, because I have a lot of things I'm supposed to tell you. I see senior 5s posting from morning to evening. And I really be like, after the 2 years, what will really be next? I don't know, maybe have some other plans, but me, I believe education should be plan A. The rest should be plan B. So why not perfect the plan A? Okay. I think that is it. So when you come here and summarize your work from the question, realize you have A, M, and F. You'll be like, what do they want? A. Do you have A? Do you have M? Yes. Do you have F? Yes. Do you have the equation that is relating all of them? Yes. Then you just do like the way they calculated here, right? The formula forces MA. You substitute very well. Under F, you put 10. You're supposed to follow that criteria. I've always told you that. ESCA mode of calculations. Then the M is the mass. So you're supposed to put it here. Then the acceleration is letter A. Okay. Then you finalize, and I told you the answer should have what units if the X is it. something like that. So those of you who know the ESCA model, you know what I mean. Yeah, the ESCA model is actually in it is also in, I taught it in physics, I taught it in chemistry, I talked about it in biology, so I've really talked about it everywhere. So it's supposed to be well conversant with that. I don't know if I talked about it in linear motion, but I usually talk about it in most of the cases. Okay, so that is it. So that's how you can summarize from the question and just transfer your solution on the answer booklet. Now, what of question 2? What are they saying? They're saying that a cow of mass 600 kilograms. So when you read 600 kilograms, you're supposed to come and do what? And so example 1 is done. We're going for example 2. Supposed to go for what? For mass. So they are saying 600 kilograms. You people tell me, are kilograms, because now this is another problem on the planet. Kilograms, you tell me, you're going to see most of you are going to fail. I have the first one and the second one. It is only those who watched my lesson of thermochemistry that are going to pass this. You tell me of 1 and 2, which one is the right format? Which one is the right standard format? Don't copy, just trust your brain, test yourself. Is it 1 or 2, 1 or 2, 1 or 2? 1 or 2, 1 or 2, 1 or 2, 1 or 2, 1 or 2? What of you are saying 2? How come? How come? You people, why are you saying 2? You give me the reasons why you're saying 2. Then I will tell whether you got that from SSA or you got that from somewhere else. Why 2? Why 2 and not 1? Why 2 and not 1? Maybe the reason will give me a direction. Someone is saying 3. I think that person is trying to seek our attention, but they will not get it. Because K is Kelvin and small k is kilo. Mutabazi Joshua, where did you get that from? Thank you so much, Joshua. But as you tell us Kelvin, even that Kelvin, that capital, that K is supposed to be capital, because that is someone. Mutabazi Joshua, you tell us. These people need to get to know your source. These people need to know your source so that they can really have ideas. I'm seeing people in the chat saying it's not a name of a person, it's not name of a person. I don't know what do you mean? Hey, you're saying that it is not kilo, like we cannot write capital K because it's not a name of a person. I don't know what people are really meaning. I don't know what you mean by that, because we have so many units in that line. Okay, capital K is for strictly Kelvin, and it was a very good physicist. And also yesterday we had we had an argument somewhere. There is a word physician, there is a word physicist. You tell me, of these two, which one is a student of physics? Is it the first one or the second one? Who is a student? Who is a student, whether a tutor of physics? Is it the physician or the physicist? Oh, so who is a physician, if I may ask? So if a physician is a doctor, so you learn that. You should also learn communication skills. Physician, medical personnel. Physicist is a student, tutor, educator of physics. So Lord Kelvin is the one who gave us that unit of Kelvin and capital K. Then kilo, it is small, So you're supposed to come and write like that, kg. So we get in and summarize. Travels a distance of 24 meters. Do you remember what I told you? That for you, you're calling S displacement. I think Ryan is supposed to give us some balance, because we gave him 20,000, but he didn't really bring out all these things well. The retardation, deceleration, which means negative acceleration, displacement S, which can also mean distance, velocity, uniform, and final, which can also be written as speed. So they are saying at a distance of 24. So as you're summarizing distance, you're supposed to come here and say comma, then you be like S is 24 meters. That's what they are giving. Okay, then you go back. while uniformly accelerating it from rest. So when they say from rest, I told you that means that the initial velocity is 0. Okay, so we shall have 0, and velocity is simply meters per second. And then they are saying that they're accelerating it from 0 to 12. So 12 is the final. So you also put comma and say that v shall be what? 12. So you can summarize from the question, or you make your own summary, something like that. Are we together? So when you come here and be like, what are they asking? They're saying that part A, find the acceleration of the car. So as a good student, the moment, I want you to listen to this, they are asking for acceleration. But there is something you really supposed to understand. That for you to get acceleration, the moment you see mass, first think about MA. But realize you don't have a force. So if this question doesn't have force, then you cannot use this equation to get acceleration because you're lacking force. So you'll be having two unknowns, or you'll be lacking two values, which is not right. So what is the best thing? That means you're not going to use mass. So you're supposed to make use of the balance to make sure that you get the value of A. So you'll be like, is there any equation of motion? Because that's what you're left with. Is there any equation of motion that really relates any of these or all of them with A? You'll be like, let me first test the first one. V is equal to U plus AT. Are we together? Then you'll be like, I'm having the V, I'm having the U, I need the A, but I don't have the time. So this one will also be having two unknowns, so it will not work. Then you'll be like, let me try the second one. S is equal to UT plus a half AT squared. Then you'll be like, I have the S, I have the U, but I don't have the time. Yet I have the acceleration I may need. So this one will even have two unknowns on top of the expression being quadratic. That means that one is a total red flag. Okay, that means the third equation, likes it or not, it's supposed to help us. So you also first try it out and be like, what of the third? So you'll be like, v squared is equal to u squared plus 2sc. On checking it, realize you have the v, you have the u, the 2 is a constant, this is the a you need, you have the s. So that means this is the third equation to help you for that case. Okay, and this is just simply linear motion. So don't think of those things of g, those things of minus. Those ones come in vertical motion. They come in under free fall. So after making all that side work, you come and remove all this. I don't know whether you people know erasable pens, but they have just come during this generation. But I don't advise them in secondary school. But they are so important when you guys reach medical school. Yeah. You will forgive me, I always use a medical school as a reference because the other courses I covered, like software engineering, bachelor's of science in computer science, most of those things were online courses through sponsorship by UNICAF. It has really sponsored my education ever since I left high school. I'm just studying because I got a lifetime coupon. And there are students who don't want to be my friends. Yet we could share the coupon because it's having 4 more empty slips for students of my choice to study under UNICAF, but it's supposed to be an additional online course to add on a skill, that you have a skill. Because anytime I can leave teaching and then go into video editing, because it is the next big thing. But our advice about all that, you first pass the BCN, then I'll tell you the harsher reality. Okay? Okay. Now, you come and do this. V squared is equal to u squared then plus 2as, because you know what you're doing. You don't even allow those people to see your side work. Don't allow them to tell that this is really a struggling student. Hide a lot from them, okay? So when you reach there now, you come and substitute and be like, my V is of course 12. Let me tell you, serious students, if at all I have any student who has already given me the answer in the chat, you're going to make it. Serious students realize the question is already interpreted by mere words I say, so they start giving me answers in the chat. I've not read the chat, but I believe I already see those serious students. And let me tell you, and now if for you are extraordinary, when you're more serious than those, I expect you to have read question 3 already. You've already summarized it and you have the answers, and you're already off. You want to come back after 5 minutes when maybe I've reached there and you confirm the answers. You're in a math lesson, but you're doing some synthesis the other side, some mechanisms in alkenes. Yes, you're not supposed to have time. Okay? Now, the u was just from rest 0 squared. Some of you be like, 0 squared is 0. Why do I really have to show that? You will fail. Now, this is where the technique is. When most of you come here and say plus, then you put here a 2. Are you listening? Most of you want to be like, since A is the unknown, let me put it last. Then you come here and put 24, then maybe you put a last. For me, when I see this work, I cross it. Because for me, I follow the ESCA mode of calculations. That after you having the expression, I expect the substitution to resemble the expression. So for me, I will interpret this as A is 24 and then S is A. Are we together? So supposed to follow that order critically. It's supposed to be very serious when we reach that point. So we are going to have A first, and then A is going to be A as A like that, and then S is going to be the 24. So who can tell me what can we do after that? Okay, I'm back. Someone had called, but I think we are back. So let me hope you have really captured that order. So it is something serious that put the two. Most of you are wiseacres. You just come here and put 48. There, I really deny you. I say that that is not a student from SSA. I don't even know about you. You're supposed to take your time as you do these things. Perfect them in senior 5. Reach senior 6 when you're a totally different person. The problem with these things, they are really forgettable. I told you that after and up to now, I'm still a student because I'm taking on some studies under masters, some studies under PhD. Okay, but let me tell you, I also read and forget. It is totally normal. But trust me, when I repeat something like the 50th time, it has really become part of me. So some of us are just too lazy to read something 5 times, but we are not really so dumb that we cannot remember something after reading it once. I read once, I forget. The second time, I forget. The third, I forget. The fourth, I forget. So it is totally normal. So it's supposed to just be locked in. Just find that one serious friend and move with them for the rest of A level. Someone who will be reading, someone who you will be reading with, they see you sleeping and they wake you up. Not someone who will see you sleeping and is like, let me also sleep. You understand? So take the A level journey kind of serious. And I don't know if you've seen those news where things are going to change. Now, for you to join medical school, it's going to be like joining School of Law. You do pre-entry. So even medicine, you can buy Daily Monitor for today. I read it early morning because they were sending it in most of the groups of medical school and so many other medical sectors. So all students who want to join medical school, you apply even when you have the cutoff points and so on. You first do certain exams because there are students who are reaching medical school and they didn't really have to reach there because the course is serious. It is people's lives, so it's supposed to be very serious. So starting next year, there shall be pre-medical entry exams. Pre-entry exams for medical school. So it will be a combination of a lot of concepts from high school and those that are really twisted. So it's supposed to be very ready. I just pray they do the same for engineering school. And when I say medical school, I don't mean doctors or I don't mean medicine and surgery. I mean dental surgery, I mean optometry, I mean public health, I mean speech and language therapy, I mean biomedical sciences, I mean radiography, a lot of courses, I mean nursing, so many. When I say engineering, I mean software, mechanical, petroleum, all those things. And they are the best courses. Okay, software engineering. So when I talk of software now, computer science comes in, such nice courses. Okay, Now, from there, I told you that where you can use the calculator, you don't really need to waste a lot of your time. But someone can be like, okay, let me just have one step. 144, then this side you have 48a. Okay, then you have the value. I think most people are giving me 3, and then you put the unit. So in mathematics, they don't mark formally, they just do that in physics. So they will give you a tick here, they will give you a tick here, like that. So someone that may be like, Doctor, I may really forget these equations. They are really hard for me. I don't know if in that first lesson I really showed you those things in the logbook. But these are cheap things, really. Make them part of you. But if at all you believe that they are hard for you, you can go for the logbook and have them. Someone tell me in the chat, did I really show you where they are in the logbook in that first lesson? The one you watched on YouTube yesterday night, the premier class? So here, Roman 2, they now asked you to determine the accelerating force. Accelerating force. Now, this is a new term. So, accelerating force, of course, is that force. Remember, I told you when a force acts on a body, then that body accelerates. So, that resultant force acting on that body is making it to accelerate. So, we can have the name of the force as accelerating force. That is extremely fine. Okay, now we are going to go for Roman 2. Roman 2, hope you people have gotten that. Accelerating force. I don't know if people, let me check your attention span. Someone raise up their hand and tell me the reason I've given as to why the accelerating force is the F. I want you to say the exact words I've said. I don't want you to now tell me other things, those things of x-axis and y-axis. And get this from me. Every time I ask you for your response, I want you to tell me what I have said or what I have ever said. So if you're not sure of it, type in the chat. So why is F the accelerating force? So we are having the mass, which is 600 kilograms, and the acceleration, which is 3. So most of you come and do this mistake and say equals, yes, the mass is 600, then you be like, the acceleration is 3. For me, when I see this, I cross it. Even if you come and complete and tell me that finally I'm having 1800, and since it is force newtons, I also come and cross this. Who can raise up their hand and tell me why I'm crossing that work? Who can tell me why I'm crossing that work? Yes, the mass is 600, the acceleration is 3, but for me, I'm crossing it. Even your final answer, it's the right one with the units, but I'm crossing it. Who can tell me why? I'm telling you that me as me, I cross it. But at UNEB, trust me, that work is going to be marked correct. But me, I don't like it. But am I in class with people because I've asked 2 questions and because it's the force that moves the body through a distance? That is wrong. That is wrong. Because they lack units. That is wrong. Proper substitution. That is wrong. FR. That is wrong. That means you people have not given certain classes time. And I don't really like it. No one is going to tell me why I crossed that work. Someone is just saying, Eska, what do you mean by Eska? There are no units in the working. Who said the working must have units? I've never said that. You people don't disappoint me. There is something. Those of you who have been listening to me very well, what did I last say? What did I last say? Someone put in the chat that the formula is on page 65. Let me check. Though this is my old logbook that I've been using for some good years, so it may not align with what you people have, but let's check and see, because I think I'm already at page 65, but I don't see the equations of motion. So I think someone can tell me where they are in the new logbook. I need the page and I need the formula. Then I need other people to confirm. Because do you see my mechanics? My mechanics are here and I don't see the motion. Yet they are there in the new logbook. So tell me in the chat, what is the page? What is the formula? There is nothing before equal signs. Thank you so much. Thank you so much, Fahad and Kent. Yeah, those are people who have been with me. What we are looking for is F and it's not there. Thank you. So about the other thing, it is equation 77, page 65. Thank you so much. So that is the simple rule, yeah? That I always like it. If at all you claim, especially for physics students, for you that is completely unnegotiable. What have I pressed? So for physics students, that is completely unnegotiable. Eh? So you're supposed to come and put that F clear. And then for me, when I see such work, I'll mark your substitution. This is math. Eh? The expression is reserved for physics. Simple as that. So I've been telling you why it's called the accelerating force. I told you that it is this force that acts on this body, then this body is moving. If at all someone finds you there standing and then they push you, you move a bit, you accelerate a bit. You understand? So the force they have used is the force that has made you accelerate. So it's the accelerating force. It has been the resultant force onto your body. Okay? So that is the simple physics or the simple math whatsoever. Now, I don't know if I'm having some people who are having answers to that already. A moment. Okay, let me hope we are back. Where is the document? It's here. So for this one, I'm not actually going to do it, but we are going to just agree that it is totally doable. That's the only thing we are going to agree on. And I'm going to hide these answers. Then I'll first ask people to do everything on their own and then tell me what they have obtained. So I'm going to give you about 3 minutes. 3 minutes, and then you tell me what you're getting there. Sorry, I had gotten an issue, but I think I've resolved it. Okay. I'm giving you only and only 5 minutes. You give me the answer to part A. Just try to be clean as I've been. Make a summary, be like, this is this, this is this, this is this, this is this, like that. But please hurry. Don't copy. If you had already copied, then please, that is too bad and I don't like it. Because now the next number we are going to cover, it's having some serious work. So please don't copy, but first do that Kawan. I confirm that here people now know the stuff. We go to the next thing. Oh, I have remembered. This is what I wanted to tell people. That if at all you want to get this formally from those who want to get them from the logbook, people are telling me page 65, and then page 65 is going to be formula. They are telling me formula 77. That's what people are telling me. Hope that makes sense. Okay. Okay, we are back here. So we are doing that number 3. When you're done, type in the chat. Part A, acceleration is this. But I want you to put the units. Then part B, you tell me distance is this. But you don't write distance D. Put the letter that means distance, put the letter that means acceleration. Put the value, put the unit. Don't put questions in AI and then you paste the answers. I really hate that from international students. They really overuse AI and you start hating it so much. So be organized, ready to work. And I'm also going to show you how the workflow is supposed to be. Then you confirm to me that you're having exactly the same flow of work. Because people know these things, but they cannot really come up with a very beautiful solution, something that is really too bad. Okay, but that is going to be rectified. So you're remaining with about 2 to 3 minutes, so you be fast. The minutes are done. I saw the first answer as 6. I don't know what people have. I'm seeing S as 8. I'm seeing S as 4. So I think I'm supposed to come in at the part of S because I don't know why people are really getting disturbed. So if me, Dr. Paul, I was a student. Let me show you what I used to do during my prime. Those days when I used to shine. So for me, I would come and say, mass, after seeing grams, I would say 500 divided by 1000 immediately. Then I get for you the answer. Then I tell you this is supposed to be in kilograms. That's why I have that. Then after something like that, I put for a comma, I go back to your question. Then I see that you're telling me resultant force is 3 newtons. Then I be like, after all, I don't have any other forces. I can just have this as F. But in case you have other forces, you're going to see the next question. I would write it like this to mean resultant. But since it's the only force here, I can just have it like that. Then I be like, it's 3 newtons. I'll be like, it's 3 newtons, okay? Then I go back, I check. They want acceleration, okay? And I tell them, that's what I used to do. Number 3 is the one having the summary. Then I come and write the answer to a very clean. I be like, oh, they want acceleration. This is math. I just tell them acceleration is force over m. Like that. Or you can do like the other thing. Like you have F is equal to ma. You put this, then you get this. That can also work. Or you can make A the subject and then you have F over M. Okay? Then you proceed and be like, okay, now A is needed. What is the force? The force is 3, and then over the mass is 0.5. I doubt if anyone has that work the way I have it. I doubt. Do I have anyone who made A the subject? And you have the work the way mine is? Do you really have these marks the way mine are? This and this? For me personally, I'm just obsessed with very neat calculations of mathematics, whether biology, whether chemistry. I just like good work. Then you go to part B. What are they saying? Distance traveled. So when they ask you for distance traveled, for me I used to write distance first. Then I put equal sign, then I put a question mark. No one has that. No one has that. I even bet $1 million. No one has put that the way it is there. S equals question mark. Then we go. Traveled by the body while increasing its speed from 1 to 7. So I come 1 to 7. So that means U is the 1 also. Meters like that. 1 to 7. Then this side, that's where I'm having the what? The 7 like that. Are we together? Then what next? I go back. They want the distance. So you will be like, is there any equation? Because now I've already used F is equal to ma. Now it's the equations of motion to really come in. So I ask myself, do I have that equation that is really relating the U, the V, the S, and the A I've obtained? Then you'll be like, yes. Or in case they're asking for distance, you ask yourself, how many equations of motion have S? You'll be like equation 2 and 3. But when you look at equation 2, it has a component of time, and we don't have time. That means it is only 3 to come to our rescue. Now, when you look at 3, it is very hard to make S the subject. So you may not stress yourself because you may even make a mistake. So you just come and be like, okay, this will be V squared, and this will be U squared, and of course this will be like that, okay? Then you come and substitute. Be like, this is 7 squared, this is 1 squared, this is 2, then we are multiplying it by 4, then we are multiplying it by the what? By the S, like that. You must write the S so well that it doesn't resemble 5, Then you be like, this is 149, no, it's 49, sorry, this is 49, and then this side I have 1, this is plus, this is 12S. So according to me, S is 4. So where did the people make a mistake? The people had 8. Where is the mistake? So as this work is being marked, as Dr. Paul, I'll look for the substitution that is really correct. Most of you be like, 1 squared is 1. You just write there 1. That work is very wrong. That's why you fail papers and be like, but I really need to go for remarking. It's not true that I really failed that paper, but you made such mistakes. Instead of 1 squared, you had 1. So this is substitution and this is the final answer. provided you have the unit, and this is S. So those are 4 scores, very cheap. They can even fix a 5th score somewhere. So that's how the things are done. Newton's laws of motion. You apply second Newton's law, then you go into laws of motion. Okay, now they are becoming more interesting because realizing linear motion was too cheap and boring. Now, let's now do this question. Hope these people have the same answers. Okay, now we go to this question 4. Question 4. Question 4. Now this one is a bit serious. They are saying 2 forces, leave alone the questions we have been doing, and they have always provided the resultant force. This time round, they have not provided the resultant force, they have provided 2 forces. So one is of magnitude 12, the other is of magnitude 9. They are acting on a particle. I want you to listen carefully. Producing this acceleration, then they are saying the forces act at an angle of 60 to each other. You note that it is not with the ground, but to each what? To each other. That is very serious. That is very serious. They are acting at an angle of 60 to each other. Then they are asking for the mass of the particle. It's even a UNEB number. You understand? It was 5 marks. After all, it was section A. So, what is the question saying? It is giving you 2 forces acting on a mass or acting on a particle. Are those 2 forces at an angle of 60 to each other? So there is nothing like the ground, but you can create the ground on your own. I want you to listen carefully, okay? Now, we are going to have these 2 kinds of students. So this is an example of one. It is serious, and it's the only one of the sort we are doing. So you're supposed to pick the concept from here. It's all about picking the concept. Okay, now we are going to come here, and I'm going to draw for you so many diagrams because we are different students, and we don't think the same way. So you may have a lot of options, and I'm going to put for you about 6. Then you people tell me which one would be the best. And even others, there are going to be additionals to this, but I'm going to just go for 6 representatives. So that's our particle. So they are saying 2 forces acting on that body. And they are telling you those forces, it is 9 newtons and 12 newtons. And they are acting, okay, the angle between the 2 is the 60, they are saying. So that is one option. Then someone will be like, okay, they have said 2 bodies. Then someone is like, what if I make this one straight like that, and then like that? That one has no problem, but now the problem comes in here. Because someone may say, okay, this one, let it be 9, let this one be 12, and then, okay, I put the 60 here. This is also okay. Because, yes, the body is here, the 2 forces are here, and between them, we have the 60 degrees. Or we can have the 12 here, or the 9 here, and guess what? Still, we have the 60 degrees here, like that. Are we together? Or someone can have the diagram in any way that they want. I have designers. See? Someone may be like, they didn't specify. Those people who just want to make their life hard. Those people are innovative. They are like, let me first do something funny. I see what I really get. Or someone can be like, let me make this one vertical. You understand? And maybe I be like, this one is 9. Of course, you cannot make this one like this, because now this is an angle of 98. The one between them is 60. So it'd be like this one can maybe be somewhere here like this. And then like this one is the 60 between the 2. And then this one is 12. You get? Someone can be like, let me make one face down. These people didn't specify, and I really need to find out what really happens after that. Okay? Then, like, I've put them on the right. Let me put on the left. And you'll be like, let me put here now the 9, and I put here the 60. So do you see what really makes such questions hard? That different students will be seeing these things in different ways. Are you seeing that? But now you people, let's label these things. This one is the first one. Are we together? This one is the second. This one is the third. This one is the fourth. This one is the fifth. And this one is the sixth. If I want you to be, honest. Which one really looks nice? Which one really looks easy to deal with? Yes, all those diagrams are correct. I want to tell you none is wrong because you've interpreted the question the way it is. That it is a particle, it is being acted upon by two bodies, and it is a particle being acted upon by two forces 12 and 9. There is an angle of 60 between the two forces, and we are producing a resultant acceleration of this. Okay? And remember what produces the acceleration, I told you it is the resultant force. That means you're supposed to struggle and find how these two forces can give you the what? The resultant, which I taught. Are we together? But now, someone tell me, in that first class we had, did I teach you how to get the angle? You first remind me, did I teach how to get the angle in that class? And did I also teach how to get the resultant? Those of you who watched forces, first remind me. Two, because of the parallelogram theory. Don't tell me the parallelogram things. Someone is like, only the third. Okay, let me go back. Look at all those options well. Yes, in all of them, we are having the two forces acting on that shaded purple particle and an angle of 60 between the two. If I need you to tell me, did I teach you the result, how to get the resultant force when you have the vertical and horizontal component, where we brought in Pythagoras? You people tell me in the chat, those who watched the lesson. So we only resolved and stopped there. So I didn't talk about tan anywhere in that class. So you don't remember me talking about tan in that class. Oh my God, oh my God, oh my God. That means you got a different class. You people, you want to tell me that even resultant I didn't teach? Like we didn't use Pythagoras anyway. Only sine and cos. Someone is like, I talked about it. Someone is like, I didn't. So what should I really take? I thought I'm dealing with serious people. Now people are giving me different things. I think now I am supposed to first really confirm. Okay, let me hear from, yes, support. I remember talking about those things somewhere. Yes, talk. The mic is unmuted. Let me first confirm that. Let me see resultant. I remember talking about that. We need to confirm together so that people don't lie to me, so that we don't make a mistake. Resultant. Okay, let me just put in the dynamics 1. Dynamics 1. Science Scholars Academy. I think this is the lesson. How can you tell me that I didn't talk about that? Calculate and add for us all those values. Now, once you add those of Fy, let me also contribute co and I add those. 5, come and say, sine of any angle is all over what? H, just to I provided this as research. Oh my God. You people have a different class, eh? You people have a different class. Oh my God. Oh my God. But it's okay. So, according to what you're seeing, so that means we are going to learn that today, which is also very fine. Oh, but it is quite absurd. Quite absurd. Quite absurd. Okay, you first tell me. Uh-huh. Which one are you picking? Which is the sketch that really looks nice for you all? Which one do you think you taught in projectile? Yeah, that's what I'm saying. I taught in projectile. I was remembering that I talked about something like that. Thank you so much. I taught in projectile. I think yeah, I taught in projectile. I was remembering something like that. I was remembering giving something of the sort time. But don't worry. Don't worry. So that lesson was you said it was forces, eh? So let me get that document. The problem are my personal assistants. No, they are supposed to have told me that long time. Let me get that document, because I think I left some good research questions that people need. How come I can't search? Okay, just a moment, because we need that. I think it's here. It is forces. Okay, people, I'm back. I was trying to retrieve the document, but I think the class is very far. I think the class is very far. I couldn't. I think let's just proceed and see how we can maneuver through it just right now. Okay. The good thing it is just something so small, yeah. But I didn't. I thought I had taught you all that. So you people, you've agreed that these ones are a bit looking weird. This is a bit looking weird, so we shall not consider it. Even this one may make our life very hard. Even all these ones looking like this, there is a way they look fun, so they may disturb you. Okay, but then when you look at two is okay, 3 is okay. So it's you to go for what you really feel like you want. Are we together? Now, maybe someone may be like, let me go for 2. So what if someone goes for 2 where the horizontal one is larger? So how are they really going to answer this? Okay, now, okay, let's do this. All of you, we are going to first answer this. Question. Okay, find the resultant. Find the resultant force in each of the following cases. So I want you to look at the YouTube video well, so that we just get those very questions I exposed at the end. Who can see them very well? I want you to take a screenshot. Let me play the video. Do you see that? Do you see what we have? You're working. So that's what we are going to consider. We had 4, 3, then we had 4 and 3, then we had 6 and 8. Then we had the other last one, which I even set in the end of term exams. So those were the ones. So those are the ones I wanted us to do. So let's do those very ones. Let's do those very ones. Let's do those very ones. We are going to do all of them. Then we switch to this one we are covering as of now, yeah? Yeah, I don't even know why I was looking for the document. I think that was Satan trying to interrupt us, because the YouTube video has even clearer work. So the first one is looking like this. This is 4 newtons and this is 3 newtons. So never forget this. So important. Now, when they ask you to get the resultant force, there is something you're supposed to respect. You're supposed to rewrite. So I expected you all to first rewrite it or to reconstruct and be a very good physics student or math student. So you come and have your diagram. So I've said you're supposed to come and reconstruct so that you come out with a perfect diagram. Yeah? It'd be like, okay, have that. Even if it is small but perfect. I think in that lesson I told you about using a ruler. So using a ruler is very key. Okay, so we have it there. So you just come here and do this. Then you put the 4 newtons. Are we together? Then you do this and then you put the 3 newtons like that. And then you make the resultant force face anywhere you feel like you want. Are we together? I don't know whether people get it when we put the resultant force here. And to create a difference, you give it 2 arrows, then you be like force resultant. This is the best thing and it is the standard. However, there are those people who prefer this. There are those people who be like, doctor, that is very fake. For us, what we know from primary is actually this. That's what you people say. Be like, doctor, this is for us, this is what we know. This is what we know as the resultant, and that's where we are writing what resultant force. I don't know whether primary, whether senior one. You understand? So that is very okay, people. But I just want you to recall what I told you. Do you remember what I told you, that this vertical force you're seeing here can actually be replicated the other side? You get the point? Do you remember that thing? That it can also come this side like this. So that you now finally come and extract out this cut triangle in lemon green. You get the point? So that cut triangle will be something like this. You get the point? Where you'll be having this. Are you seeing something like that? But I don't know whether people can see where the particle is. So we are assuming that our particle is here. Very, very important. Do you see that? I want you to follow. Then do you see that the 3 newtons will be here? Do you see that the 4 newtons, we just transfer them to here? And you see that the resultant force is actually here, resultant. So most students also is find an issue with placing our particle. So most students always come and put the particle here. That means that student crammed and they don't know what they are doing. So the best thing is to follow the right protocol, and then you come and put the particle where? Here. But trust me, no one will even bother about where your particle is. They will just consider a correct force diagram, and trust me, this is a score. All force diagrams are marked in mechanics. So that is the perfect thing I really expect. So if I told you well conversant, you can see it is very okay and very correct. You just need to make sure that you maintain the direction. So someone who has this car thing is very okay. Someone who is having this is very okay. Though the best is this first one because we are getting it exactly from our diagram. But trust me, it is the same thing. They just tell you forces acting. Why they use the word acting in math is that they don't tell you whether pushing or pulling, because you realize that in our first part, the 3 newtons, it's like it's pulling the particle, but then here it's like it is pushing onto the particle. That's why you just use the word act, because acting can be pulling, acting can be pushing, so that they don't make students develop tachycardia when the diagrams are different. Are we together? Yeah, you need to really understand that. Then, I may ask you all people, you all know what we call Pythagoras, isn't it? If you people know Pythagoras, can you really fail to get the resultant in this case? Do you see the role of that cut triangle? The cut triangle is here to help us understand that this is 4, this is 3, and then we obtain this by Pythagoras. So I'll come and tell you that that force is obtained by Pythagoras. Or Pythagoras theorem. Now, I want you to tell me in the chat, we are obtaining force. Is force a vector quantity or a scalar quantity? You tell me in the chat. Tell me in the chat, all of you. Is force a scalar quantity? I told you that in that very class. What did we say? Is force a vector quantity or scalar quantity? Think all of you have passed it. Vector quantity. That means we not only stop on magnitude. So this force is a vector quantity. So because it's a vector quantity, we shall need the magnitude. Then you tell me, do you know how we give the direction? I've recalled I taught this in projectile. So since force is a vector quantity, we need its magnitude, which we can really obtain, and then the direction. Okay? And this force we are talking of, in most of the cases, it is the resultant. Get the point? Because we are having two different forces acting on a particle, but we would really want to know what is the resultant force, what is its magnitude, and in which direction is this body really going into. So have it in mind that direction in math is measured by angles. Measured by angles. I don't know when I talked about this, but I just believe I'm just having a feeling that I'm repeating myself, things that I told. So have it in mind that every time you're getting resultant force, since it's a vector quantity, don't stop on the magnitude, proceed and get direction. How? Get the angle. So someone may be like, which one is that angle really? So remember that we are involving the resultant force. Of course, the angle cannot be 90. The angle 90 is just between the vertical and the horizontal component. Of course, between vertical and horizontal, it's supposed to be 90. So that means you're remaining with only two spaces, this space and this space. Are we together? So I'm having this angle alpha, I'm having this angle theta. So you tell me, which one is the actual angle you think they need in this case? When were they getting me? Resultant force is a vector quantity. Vector quantities have both size or magnitude and direction. How do we measure direction in math? By angles. So the angles we have in a triangle are only 3, but this 90 shall be out because that one is just prototype. It is stereotyped. that between vertical and horizontal we strictly have 90, so no big deal. That means we're remaining with only two spaces of angles. That is the space where you're seeing alpha and the other space of theta. So you tell me, which one do you think is the right angle we need in this case? People are really struggling with the spelling of theta because it has direction. Okay, you people, you may read, if at all you're good at reading textbooks, both angles may be okay provided you communicate in your answer. But all of us are going to be using this theta. Why this one? Or why the theta? Why the alpha? And I'll go with alpha for reasons that I'll tell you later. We are going with alpha, so it's always alpha, measured by angles, and it's always denoted with alpha y. In most of the cases, the questions give you the theta, and we are going to see that. So why we go with alpha? Because it's with the ground or it's with the horizontal, but even the other one is okay, because you can conclude and say, yes, it is the angle beta with the vertical, or you can say it is the angle alpha with the horizontal. So you just note that, that both angles are okay, though one is always with the what? With the vertical, like this one beta with the 4, and then this one, the beta is with the vertical. So that angle is okay. Even this alpha is okay, though for it is with the horizontal 3. But as students of Sun Scholars Academy, it's better we be uniform. And I prefer when we have it as the horizontal one, or as the alpha, which is the angle with the horizontal. It's always better that way. Okay? So every time they tell you to get resultant, never forget the what? The angle. So I think we are going to do this one. We're only doing the first one, then you people are going to do the second. So then the other thing, someone may be like, but doctor, now things are becoming hard. But they are not. I want you to look at this. I want you to look at that diagram. So we have agreed we are having our particle there, okay? And then we have agreed that what? We are having our resultant force here. I want you to look at that. Then you all know that, of course, it's like this. These ones are what? 3 newtons. And then these ones are 4 newtons. You saw that? Never forgetting that. Okay? These ones are just one arrow. These ones are supposed to be 2 arrows to show resultant. So you're supposed to be keen at that. Now, if I tell you that all of us are going to be going for this angle, and we are calling it alpha, I want to ask you, how do you really think that angle is going to be obtained? I told you trigonometry, and I gave you a very good introduction in that lesson 1. And I told you that always look at what you have and then get to know what you're supposed to use. Are we together? So in trigonometry, in case you are getting a relationship between the angles and the sides, you use SOHCAHTOA. Okay? So in case you're looking for this angle, you look at these two. They are the ones you have. You're having the 4 and the 3. So when you look at 3, 3 is where the angle is sitting or lying. That is what they call the adjacent, where the angle sits, where the angle lays. Then when you look at this 4, it's the side the angle is facing. So that means that 4, or the side where 4 is opposite to the angle. So this is opposite. That means the only one that can help us, or the only trig function to help us get the at alpha, is the one that takes on the O and the A. And from SOHCAHTOA, it is the TOA. Okay, and that simply means that tan of that angle alpha shall be the opposite over the adjacent. I told you that in trigonometry, even in that first class, so I don't want to overspeak. But then I want you to recall something generally, that this one is the force in the vertical plane or the y plane, and then this one, the 3 newtons, it is the force. I mean the force, not the angle. So the 4 newtons is the force, in the y plane, and then the 3 is the force in the x plane. You all know that. So that means if you're to get this angle for the resultant, you're supposed to say tan inverse opposite over what? Over the adjacent. Are we together? What does that really mean? That means that always, I want you to listen. This is what you need. Always, 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 alpha shall be the tan inverse of the opposite where opposite shall be the force in the what? Y plane over force in the X plane. Just this. So you need this so much. Someone may be like, what is that alpha? Where this alpha is the direction of the resultant. Someone may be like, but it is an angle. How is it becoming a direction? Direction of the resultant. But I told you that directions are measured in forms of angles in math mechanics. Direction of the resultant force. Very important. Then we have agreed that this one is the vertical what? Vertical component. That means this lesson is becoming 2 in 1. Then this one is the horizontal component. This one is the horizontal what? Of which the word components I briefed you already even in that first class. So I want you to take a screenshot of that and then post on your status so that people can learn something good today. Yeah, that when you have the vertical component, horizontal component, the angle or the direction of the resultant is the alpha with reasons why. And from SOHCAHTOA, we realize that we can use tan. Let me first stop share. Those who are writing in the screen, please be disciplined. Just simply follow up. Don't write in the screen. I don't want to remove you from the meeting. Just be organized. Okay? Something like that. So always you can see that alpha shall be tan inverse of the opposite, which is the vertical component, and then over fx, which is the horizontal component, just like that. Just like that. So never waste your time. So when they ask you for resultant force, we expect two things. We expect the magnitude, we expect the what? The direction. The moment you miss any of those, you're gone. Hope that has made sense. Okay, now for that very question, I'll just write below this and tell you that in case that was the question in place, if I were the student, I would come and say solution. Or let me first give you another note. Remember we said the resultant force is obtained from Pythagoras. Let me see if I still have some space there. I wanted to fix it there, but I think I can't. But let me just try to fix it here, people. So you all know that we are saying that this thing is obtained from Pythagoras. So I'm going to put it there, Pythagoras. What are we going to write? Who can generate for me the Pythagoras theorem? Who can apply Pythagoras here so that we get the value of the resultant force? So if I told you that the questions we have been doing before, resultant force, we have been just calling it F. But now this is a question which has already provided its forces. So as you denote a resultant force, you're supposed to write F and then the subscript capital R. Very important, okay? Now you're supposed to come and say theory squared, hope you all see that, okay? Plus force squared, which will be FR but squared. I know that people are seeing that. Then from that, guess what? You're going to be having something like that for you to get FR alone, we apply square root on both sides. Then here we shall have 3 squared, then 4 squared. Are we together? But remember the 3, we all know it is the horizontal component, which was Fx. And then we all know that 4 was the vertical component, which was what? Fy. What does that mean? That every time you want to get this one, remember it's like our C. You all know this thing from Pythagoras, that C is the root of a squared plus b squared. And from the triangle, you all know that we always tell, of course, this C is always the slanting one, which is our resultant force in this case. A is usually the what? The horizontal component, and B the vertical one. So to get the resultant force, sorry, just get the square root of the horizontal component squared plus vertical component squared. As simple as that. So you say that that is really hard? Not at all. So I was saying that this one we shall obtain it from Pythagoras. And the question is how? So for you to get the resultant force always, which is FR, simply get the square root, get the horizontal component, square it. After get the vertical component also what? Square it. So I want first people to give me to really assure me. So you will find the same things in projectile motion. So make sure you understand. So I want you to look at that part of finding the resultant force. So what you've obtained there is what they call magnitude. So what the theorem is really delivering is the magnitude, like the value. But then we have what we call direction, which is measured in terms of the angles, something like that. And you people, don't be confused about us having angles in terms of direction. That shouldn't really confuse you. Why? You people have heard of the compass direction. It's called the compass direction. That means it gives directions. You know, that is the north, this is east, this is west, and this is south. You all know that if at all I put a line here, and then this is maybe something like let me say 60 degrees, you all know that this direction is called north, 60 degrees, as you move towards the what? The east. So do you see? It's a compass direction, so it's supposed to give directions, but then we use angles as we give those directions. So in mathematics, angles and directions are just like this. They're just together, they're just siblings. So hope you understand that. If at all this is maybe something like, and I put here maybe 40 degrees, you know what that means? That means that the direction is west 40 degrees as I move towards what? South. So it's a direction, but I'm using angles to really make it perfect. Simple as that. So those are the two things you're supposed to really master. So I want people to really assure me that they now know that to get the resultant, get the square root, the square of the horizontal component plus the square of the vertical one. Then to get the direction, which is alpha, you simply get the tan inverse. I know people are not getting the tan inverse part because you've refused to watch trigonometry classes, yet it is very key. But if at all I'm to brief you slightly, of which I think I did, I'm not so sure, but do people get this part? Are you seeing this part? This part I had tan alpha O over A, but then I brought the alpha alone. I don't know whether people get that part. Do people get that part? You tell me. Do people get this part when I have tan alpha over? Then here I get alpha. So when this tan goes the other side, it becomes tan inverse. How do you press that on the calculator? You press shift and tan. But I was going to tell you that as we calculate it. So if you want to press the tan inverse, you simply press the shift and then you press the what? The tan. Yeah, our features are jammed, but we are back. So I was telling you that when the tan goes the other side, it is tan inverse. How do you press it? Shift and what? And tan. That is all. So I don't know if people are ready for the very first example. To apply the first one and then also the angle. So all of them are giving us the resultant force. Nothing much. Okay, people have stamped in. So the very first number, I told you you're supposed to first model it very well. And you all know that on remodeling, we had this. So you're supposed to have it. Angle of 90, never forget. So we agreed the particle is here. Then we had this, I think, as 3 newtons. Then we had this as 4 newtons. So this is the student alpha. Then you show these 2 arrows. Then you'll be like, this is the resultant force, like that. So when they ask you for the resultant force, you know I need the magnitude and I also need the what? The direction. So you come and say, to get the magnitude, But they don't award formulae in math. So you just go straight out with 3 squared plus 4 squared. And then this one gives you what? 5 newtons. And then you're done. So you get a mark here, you get a mark here. So whatever we have been doing, we have been just wasting time to make sure that makes sense. Then when you need the alpha, you just be like, okay, alpha, I'm supposed to just simply set an inverse, okay? Then vertical component on top, which is 4, then horizontal component down, which is 3. Press your calculator, you're getting an angle in degrees. So make sure your calculator is in degrees. Tell me that angle. You people, hurry, tell me that angle. Tell me that angle. Since we are getting an angle and we want it to be in degrees, that means that even the calculator is supposed to be in degrees. Someone is giving me 53.13. Those who attended my old classes, you are very well aware that angles are supposed to be to 2 decimal places. So you're supposed to take that serious. So you're supposed to consider it as you give me the responses. Okay, well, which is the answer? I told you that there are some calls that I'm supposed to get and I pick, okay? Yeah. Yes, I'm supposed to respect class time, but there are calls that are inevitable. Since I'm in a life-saving sector, so there are calls that are supposed to be picked. What if it's someone's life? Yeah. Yet I'm this side saving lives that are not understanding. Where are we? Which is the angle? Which is the angle? People are not giving me the angle. Which is the angle? 53.13. Okay, that is it. So there are supposed to be 2 dp's, 53.13 degrees, and then yeah, that is it. So you get those 4 scores. So sorry, there are 5 because I told you that even this one is supposed to be worked on. So those are 5 scores banked. So at least you people learned that today. I didn't know that I didn't even teach resultant force. It's what I was supposed to begin with. So this is the question you're going to do, all of you. So you get the resultant force in this case. So we are having 8 newtons here. We are having 6 newtons here. Yes, that's what we are doing. So hurry. So you're supposed to get the 5 scores. You're supposed to have the right force diagram. Yes, I want to see which force diagram people are going to have. Then get the resultant force, then get the alpha. Please don't just press these things in the calculator. It is easier to pass them when you just press. But presentation of work is very key. So you do that. We do the number. And then I didn't know that this wasn't taught. So we do the other number. I give you assignment. I'm giving you 4 minutes. I'm giving you 4 minutes. So you be fast. 3 minutes actually. 4 minutes are many. So you have less than 3 minutes. When you're done, you just say I'm done. Don't give us the answers. Just say I'm done. But please draw that diagram on your own, because without the diagram, they don't mark the other things. I don't know if you are aware. Without the diagram, they don't mark your other work, because they believe it's the first diagram to take you to the other things. And those are the small things that make mechanics hard. So have it in mind that angles, they are always 2 dp's at your level. So angles, always record them to 2 dp's. Very important. Always record them to 2 dp's. When you're done, you just type I'm done. When you're done, you just type I'm done. I'm done. But please hurry. Please hurry. Okay. Let me hope whoever is saying I'm done, you're actually done. You're not cheating on yourself. So using this very diagram, I'll first come and be like, resultant force is supposed to come here like that. Also listen carefully. Then you'll be like, oh, well, it's like that. By the way, people, as when you get that alpha, okay, yeah, you've tried to share it, but I advise you make a conclusion. Yeah? Yes, if you can't make a conclusion and say that you say that the magnitude of the resultant force, come and say that the magnitude of the resultant force, the magnitude of the resultant force is 5 newtons in the direction of 53.13 degrees with the horizontal. Yeah, with the horizontal is very important. Remember your answers, one should have a response. Yeah, so that should be your response. Yeah, with the horizontal, very key. You show them the magnitude, you show them that you know that resultant force is a vector quantity, so it has both magnitude and what? And direction. So for the second one, I'm not going to rewrite that. You should be knowing it. Now, for this case, when they ask you to do all that, I told you just try your level best. Try and shift this force here. You get the point? So come and put it here. Be like, this is where I'm having the 6. So if you're to draw all those things again, you will have such a diagram. Just don't change the format of the question. Have here the what? The 90 degrees. Then have here the 6, that. Then have here your 8 newtons. Then have it in mind the particle was here, so also maintain the particle here. Hope people have maintained the particle throughout. Get the point? Then your direction of the resultant force, because it should also be acting on the what? On the particle. That's where it is. Then you choose any angle that you want. You understand? But remember, this one is the vertical, this one is the horizontal. So if at all you go with the vertical, it is okay. If you go with the horizontal, it's also okay. But I said as students of Science Scholars Academy, we shall always go with the horizontal and we shall always use what? Alpha. Something like that. So if you don't have that diagram, you've lost marks. If it's not like that, you've lost marks, especially if you don't have that sign of right angle. Some of you are like, I've not done, but I can do that in an exam. Okay. Let us pray for you. So you come and label this well and let us know that this is the what? The resultant force. There are people who are very organized. They even come and do this. I taught you this in inequalities and told you that means magnitude. Someone writes it like that to show the examiner that here we are real math students. That's magnitude of the resultant force. Then you'll be like, it's equal to the root of which value? 6 squared and then 8 squared. And then you get 10 what? 10 newtons. Then they mark this, okay? Then after that, you come for the direction. Be like my alpha, it will be the tan inverse, okay? Vertical component, what is that? 6. Horizontal component, what is that? 8. You people, what do you get in the calculator? 2 dps for the angle. Is it a must for the particle to be at the sign of the right angle? What if someone had the alpha at 6? It is okay, provided your angle is going to change, and as you conclude, you tell us that that angle is with the vertical. That's what I've said, people. People having different angles, so what should I take? Someone is having 36.89, another one is having 86.87. So which one is the right angle? Tan inverse of 6 over 8. Your calculator should be in radians because we want to get our, sorry, the calculator should be in degrees because even what we want to obtain is supposed to be in degrees. So it is 36.87. That's 6.87 like that. So that is it. Do you see that? Then you conclude and tell us the magnitude of the resultant force is that, and over with or in the direction of 36.87 with the horizontal. Everyone can see that the horizontal is 8, the vertical is 6. As simple as that. So that is it, people. That is it, people. Now, you're going to take a screenshot of part C that we had, and that one will be your assignment. Will be your assignment. I want you to look at it. It's also here at YouTube. You can check it out. Do you see that part C? Do you see that part C? Do you see that part C? Part C was a bit serious. Part C was a bit serious. I don't know. Did we do any number of that sort? It's a bit serious. It's having down it is 2 and 8. The other side it is 2, 4. On top we are having 10. It's a bit serious. Then the other side we are having 1. I don't know why it was like that. But it is always easy. Eh? Now there is no rocket science there. You just really need to get the resultant in each of the cases and then proceed. Those many forces, that is just design. Okay? Because now they had something like this. You can have maybe here something like 3 newtons. You can have something here like 8 newtons. We can have something here like only 1 newton. Then we can have maybe 4 of them. Then here we can have only 1, maybe only 2 newtons. Okay. Then even here down we have only one, maybe something like 30 newtons. Do you see that? So they ask you for the resultant. So for you, don't waste your time. You first tell them, according to me, I can see that these ones are going to make 11, but this one is 30. So that means the downward forces are really greater than everything. So you'll be like, down I will have 30 minus 30 minus the summation of 3 and 8. Do you see that? You can even put this in square brackets. Then you conclude and tell them the result shall be 19. And that 19 will be what? Facing down. Then you come and tell them, when I add these two, I'm seeing 5. But then the other side, I'm having something like 2. Like when I consider the summation of these two, it's 5. The other side, I'm having a 2. So that means that this side will win. And as that side wins, that means it will be a summation of 1 and 4, okay? And it will be subtracting the 2. Square bracket, then I'll be like, this side will win, and guess what? It will be a 3, and there will be 3 newtons. You see that? Then you draw your diagram. So your diagram will be having the 19 facing down. You get the point? And then this side, you will have the 3 newtons. And then you will have this here. And of course, the particle is the one here. You get the point? Then you proceed. So proceeding is your assignment. Okay? So that is the simple hint. So don't think things are hard. They are not at all. So that's the hint. Then proceeding shall be your assignment. Something else came up in our class. Okay, you take a screenshot of that. Hope people have gotten that. Have you learned how to deal with such bodies that have so many forces? First, find out the resultant in terms of direction. Okay? Then after that, get one single diagram. Then deal with it like the way we have been dealing with the rest. So it's just cosmetics in math. Someone has posted their diagram. Yes, your diagram is wrong because you've not used the ruler. Very wrong because you've not used the ruler. Yes, that's the first red flag. Now, people, someone may be like, let me tell you, all what we are covering now was not actually planned for. Because it is already 2:30, we must have left this place long time. But because of that I really wasn't sure whether we had covered or not, it has really brought problems. So if at all you have a very good memory, this is where we are. And it's where we are supposed to go back. So that's where we were. So we are supposed to go back there. So we had said we are going to go for option 2, which had 12 and what? 12 in the horizontal and then 9 the other side. You know, some of you have already forgotten that that's the number we're actually doing. But the last one we are doing, then you go with assignment and yeah, we leave this place. Then we shall come back for Newton's third law. Okay, example 4. This is how it was. I'm really sorry that I thought resultant force was actually taught because it's a serious concept. So it has taken our time for Newton's third law. Remember, we have physics in the afternoon. So we are already 3 minutes into physics time. But we are going to rectify that. Apologies. So this is 12 newtons. This is 9 newtons. I told you about the sketches already. And this is 60. Are we together? That's what the question was saying. If you recall, hope we are still together. So the question, you see, they say that two forces are acting like that. Are we together? Then they say producing an acceleration of that, and those forces like, so they want the mass of the particle, they gave us acceleration, which is 3.65. So you're just summarizing. So you come and be like, okay, these people provide the acceleration, which is 3.65. And they have even put the unit like that. Okay? Then you'll be like, well, You're going to see why I'm going to put it this side. So it is 3.65 with its unit. Then you'll be like, these people are asking for the mass of the particle. But the only formula that can help me get mass with the use of acceleration is this. Well, this is like your side work. So you'll be like, I have the acceleration, these people want the mass. That means I should look for ways of getting force. Then you'll be like, but I'm having two forces, 9 and 12. So which force should I really put here? Then you recall that this force is supposed to always be what? The resultant. So you ask yourself, how can you really get the resultant of these forces? Then you'll be like, this is really a different concept. Because for me, I'm used to getting such. Maybe if 12 was here, then 9 was here, then I could use what? Pythagoras. But then 9 is at an angle. 9 is bending a bit. Can you really just use Pythagoras there? No, you can't. So this is where really problems arise. Okay? This is a bit serious. I don't know that people are getting the idea. This is the sketch that we have obtained from the information they provided. And then according to this formula, for you to get the mass they want, you need acceleration, which you have, and force. But we already have two forces. But remember that this force is supposed to be the what? The resultant. So we're supposed to consider these two forces and get the resultant. But recall, the resultant we have been covering is for these ones that are already at an angle of 90 degrees. But now to make matters worse, these ones are already at an angle of 60. You get? Now that means you're supposed to make sure, so you're supposed to resolve this one. Hey, now let me tell you what you're supposed to do. So those things we were doing, all those things we have been doing, we had only the vertical and horizontal components. Only, we didn't have anything else. Okay? But now for this case, where we have 9 and 12, when you look at 12, 12 is having the horizontal component. This one. This one is already the horizontal component because that's what you chose. Is already a horizontal component. This one is already a horizontal what? Component. You get the point? What does that mean? That means it has no vertical component. It can't. It is already lying horizontally. So it has no vertical what? Component. But then when you look at this 9 is a bit weird and it's creating a lot of questions. And if at all you've been a good student at resolving, you can see something fishy. Which one? You realize that this 9 can be resolved vertically and the same 9 can be resolved how? Horizontally. Anyway, the people see that. Can people see that that 9 can be resolved horizontally? Only the 9. This 12 can't because for it is already what? It is already vertical. It's already in the horizontal plane. Sorry. It's already horizontal. It's already in the horizontal plane. You cannot force it to become vertical. How? But when you look at this 9, this 9 can compress this 60 and then we create another force here, which is a 9 cos 60. Whether people can see that. Then when this one becomes 9 cos 60, this one becomes 9 sin 60. If you can see that, then the lesson is done. Because that's the hardest thing. That's the only hard thing here. Is realizing that this 12, there is what they call the parallelogram rule, where we use cosine rule. But I'll give you that as an option in the future. But first get these basics. Because now I know if I begin explaining the cosine rule, that will be another problem. Because it has a lot of things to do. But I believe this can work for those who have been getting the concept. So 12 is already horizontal, has no vertical component. But this 9, you can resolve it vertically and horizontally. When you compress the 60, you have 9 cos 60. When you resolve it vertically, you have only and only 9 what? Sin 60. I don't know if people are getting that. Do you people get that? Because now the diagram is going to change to what we want. I don't know. Have people gotten me? That for you to get the resultant force, always make sure that the things you have are like this at an angle of what? 90. If at all you have anything that is bending, so this one is okay because it is in the format you're used to. But then this one is bending, so force it to become straight. But you cannot just force it to become straight because for you to resolve it, that means you need both the vertical and horizontal component. So yes, as you're making it straight, don't leave out the horizontal one because it won't be fair. I don't know whether people are getting me. It won't be fair if you do it that way. So if at all you're saying that is fine, let me redraw the diagram. So when we redraw the diagram, this is how it's going to be. The diagram is going to be having this and this like that. So this one will now be an angle of 90. This one is going to be 9 sine 60. But then this side, we had 12 already. And on top of that 12, the 9 cos 60 came and added it off. Never forget the degrees. You know whether now people are getting me. Now you can come and attach those what? The values of those angles. Now, there is something I want to teach as well. You can press your calculator and use 5 dps like the way I did in the previous examples. But then I want to teach you something. You learned that sine 60 is the same as root 3 over 2. This is math. So this is taught in trigonometry and I taught. Okay? And I told you sine is the same as cos. Now you people, I want you to tell me which angle should I put here such that it will also give me root 3 over 2 as sine 60, but I'm putting it on cos. You tell me in the chat. Have you gotten me? Sine 60 is root 3 over 2, and that is standard. So you tell me which angle should I attach to cos that it is the same as sine 60 and both will give us root 3 over 2. What did I say? 30. Thank you so much. That those two angles are just supposed to be adding up to what? To 90. So the things you're supposed to learn. Then the other thing, there is another standard one. Though for it will always be direct in the calculator. Yeah, that one will always be direct. But I always find issues with this. What do I mean? For example, press your calculators right now and put in this. Remember, it is 60 degrees, so your calculator should be in degrees. Tell me what you get. Tell me what you get. Tell me what you get as I tell you something here. So you're supposed to also understand that sine 30, as in sine 30, when you press your calculator right now, you will get 0.5. That means sine 30 is a half. But I taught this in trigonometry, which you have on the drive. Okay. Then here, the angle I can attach to cos, and it will be the same as sine 30 is sine 60 degrees. So is cos 60 degrees. So even cos 60 degrees, when you press it on the calculator, you're expected to get what? A half. Are we together? Now realize you're getting points, and you're supposed to write it 5 dps. But again, this is what I always prefer. I always prefer someone who is going to be like 9 is 9, but sine 60 is root 3 over 2. Then someone comes and writes it as 9 over 2 root 3. Yeah, it is always nice. It is no problem. 9 over 2 root 3. And then those are your what? Those are your newtons. Just because this one is 9 over 2, so for it may look weird. But assume it was something like maybe 8 sine 60. So when you say 8 sine 60, when you come and be like 8 into root 3 over 2, the 8 over 2 is going to become a 4 root 3. And 4 root 3 is even looking nice. Do you understand that you've not yet started rounding off your answer? So it is always good you round off when you reach the final answer. However, that figure to 5 dps is actually not wrong, because the minimum as far as the old curriculum is concerned, it was 4 dps. So for us, we have been using 5 to be on the safer side, because the more the dps, the more the accuracy. So that means we are just safe. So those 5 dps you've gotten from the calculator, they are okay, but also learn this technique. Okay, then come this side. So you can see cos 60, we have said it is the same as sine 30, both are half. So this will be 9 over 2. 12 plus 9 over 2, that one is inevitable, isn't it? 16.5. Are you getting 16.5? Are you getting 16.5 for 12 plus 9 cos 60? That's what I'm getting, 16.5. But me, I'm getting it from my head. Because I know cos 60 is a half, 9 over 2 is 4.5, 12 plus 4.5 is 16.5. So you should also be getting those ideas. Okay, so this one is 16.5 newtons. Are we together? So that is now the new value. And then this one is the new value here. Are we together? But now, okay, I may pardon you, since this one is a fraction and then it is a surd, it may give you a time. So we can write that value, the 0.1 that you guys are having. Is it 7.9? Okay, it is 79423. 79423. So it is 79423. But also learn the other technique. So this one is okay. I've removed the other one because it was a fraction and again a surd, though it's always better for it to look like this. But anything is okay, provided you have the 5 DPs and you're sure you won't make a mistake. So when you have those things, I think people can see why in the beginning I told you that we shall always go for alpha, because we assume this angle originally in the question is the theta, because there are questions that will give you theta, so it's supposed to be used to alpha as the direction for the resultant. So when you come here and do this, you'll be like, my resultant will be here, like the particle is here. I don't know that people are following. The particle is there. Then you'll be like, okay, this will be the resultant, like that. Are we together? Then you'll be like, the angle is better with the horizontal. Then you come and put it there like that. Then you'll be like, I'm supposed to come up with the complete triangle. So you transfer the whole of this the other side. Then you're like, that means I'll put this here and my angle will be there. Okay? Remember, that is not the sketch that is marked. So after all that, you now come and resketch. Now, this is the real sketch that is going to earn you marks. So you come and follow all that. You can just put a simple card dot to show the particle. Don't put something big. So you come, show this. Don't forget the angle of 90. Someone is like, but why does that angle of 90 shift? The horizontal and vertical components are supposed to be at an angle of what? Of 90. So here you come and put your 16 point what? 0.5 newtons. Then this one going up, it is the, is it 7.7? Is it 9423? Hope that value is right. Then like that. Then don't forget the resultant force with 2 arrows, then capital F and subscript capital R, like that. So that is the diagram that they are going to mark. Hope people can draw these diagrams on their own. Are we together? So you people, do I really need to get the resultant for you? And the question is saying, find the mass of the particle. So no need of getting direction. But if the question asks you for the resultant force, get both the magnitude and direction. But here they skipped the resultant force part. They only need mass. And the mass comes from magnitude only. So when you get magnitude, strictly connect to what? To the mass they want. So we are going to come and say the resultant force. What will I do? I will have, of course, the horizontal component first. Since it has a point, I prefer it being in brackets like that. Then even the other side, 7.7, is it 9423? Then squared. You people just press that in the calculator at once, get me the answer. It is in newtons. So I told you, for things you can press in the calculator at once and get the answer. Don't stress yourself with pressing a lot of things. Press those values, please, and tell me the answer. You people, you have delayed. Let me get my value here. People, we are using 5 DPs. 24829. So it is 18.24, like that. Let me hope people are giving me something right. Which value is coming after the 9? Which value is coming after the 9? I taught you rounding off. I think it was in iterative methods as well. Which value is coming after the 9? You people, you want to tell me that you don't know how to round off. So 8 is coming after 9 and you're just truncating. Are you really serious that the value after 9 is 8? It's an 8 that is rounded off to 9. I mean, oh, okay, thank you so much. So what is coming after 8? What is coming after 8? 8. Okay, thank you so much. So that is the value. So when they ask you for the mass after, you just simply be like, okay, the mass is just force over A. Then you tell them what is the force. 18 point, this is 24, this is 82, this is 9, and then the acceleration is 3.65. So just get our answer, divide by 3.65, and you don't even need to rewrite it. You just use that long one on the calculator, provided you maintain the DPs. So you get the answer, same number of decimal places. So what is the answer you're getting? Which answer are you getting? Which answer are you getting? Final answer, divide very fast, divide very fast. For me, I know it already. I just want to check if people really calculate. There are those who wait for people's answers and then they just copy. So it is 99953. Of course, kilograms. Yeah, that is it. Someone may be like, but which value, which machine will really measure that? Just write it like that. What they concentrate on is the angle. It's supposed to be to 2 dps, but these other things, just write what you get. Hope that makes sense. People, that is the question. That is the question. That is the question. That is the question. I don't want us to waste a lot of time there. Now, I'm going to give you an assignment. You can try it. Then, of course, we shall come back, and I will have confirmed whether we are supposed to do the thing concerning vectorial form, and then we shall do a lot of work. So these are the numbers you're supposed to go with. Let me see. Okay. Let me first dictate some good questions here. So get where it right, get where it right, get where it right. Yeah, for the first time I'm going to dictate. Let people be active. Those who won't write, it's up to you. So get where it right, get where it right. Get where it right. And I'm dictating once. So we go the first question. Let me first open my email here. I get you some from the SSA book concerning this first class. Then we are back. We shall go for the next concepts. I think this is the question. A body of mass, 200 grams. You're right. A body of mass, 200 grams, experiences a resultant force of 7 newtons. A body of mass, 200 grams, experiences a resultant force of, a body of mass, 200 grams, experiences a resultant force of 7 newtons, 7 newtons. 7 newtons. Calculate the distance. Calculate the distance. Calculate the distance. Calculate the distance. Calculate the distance traveled by the body. Calculate the distance calculate the distance traveled by the body from rest. Calculate the distance traveled by the body from rest. In 2 minutes. So realize I've given you grams that are supposed to be converted to kilograms. I've given you minutes that are supposed to be converted to seconds. So that is the first question. So you're supposed to take it serious. Okay. Then we go for another. The question is saying determine the resultant force. Determine the resultant accelerating force. Determine the resultant accelerating force. Determine the resultant accelerating force of a truck of mass 1 ton, of a truck of mass 1 ton. So you make research and find out what a ton is. Yeah, you really need to appreciate all that. Do people know the spelling of ton? Do people know the spelling of ton, or I'm supposed to dictate that? So it's 1 ton, or what they call 1 metric ton. Let me educate you. So it is like this, 1 ton, or what they call the metric ton. So I've said calculate the resultant accelerating force of a truck of mass 1 ton traveling from rest to 2 kilometers per hour. Now I'm giving you kilometers per hour. You're supposed to convert to meters per second. You can even do that from the calculator without pressing anything. To 2 kilometers per hour, covering a displacement, or getting displaced, or covering a distance. All those are the same things. Covering a distance of 8,000 meters, or a distance of 8 kilometers, or 8,000 meters. So 8 kilometers, 8,000 meters. Yeah, those two numbers, they are very serious. If you pass those numbers, you've actually passed. Okay? Yeah. So whoever has written them in a very good handwriting, you post them in the different premium groups. And if you have a good handwriting, send it to the support assistants. And if at all it is very good, I'm going to give it as assignment in the channel. So for the first time, I've dictated assignments so that those who don't really get books during class are really stopped out. So our next stop shall be more complex examples. So sorry for the resultant part that came in. We have not been in position to capture 100% of the lesson targets. But if at all we count the resultant part, we have hit 90%. So we are not too bad off. More complex examples, and then we shall get Newton's third law. Okay. And then we shall capture lesson 2 points. Remember, there were some lesson 2 points that we are supposed to be handled. Otherwise, thank you people for attending. Yeah. So you will allow me sign out. So keep updated in the channel about when the physics class is really going to be started. So as a tutor of Science Scholars Academy Uganda, SSA, then those who may really want to reach out to me directly, that is my contact. I may be poor at response. That's why we have support people. Otherwise, thank you all for choosing SSA and thank you for attending. I don't think we have any concerns in the chat. Yeah. So we shall handle these mechanics because it's the only thing that is really missing on the math drive and coordinate geometry too. So we shall handle it slowly at our pace so that you really understand these concepts in bits, but in a way that is really worth it. Otherwise, bye-bye.